உங்களுக்கு கேக்குதா லாவண்யா?
கேக்குதா மேடம்? ஹலோ மேடம்.
ரிசீவர் மேடம். ஓகே.
Hello, ma'am. Good morning.
మేడం స్పీకర్స్ ప్రాబ్లం మనం ఎవరు మాట్లాడమో
Hello.
మేడం
Hello, ma'am. Very good morning.
Okay, very good morning.
Yeah. Madam, very good morning, madam. This is Dr. Janathan Raju.
Yes. Good morning, sir.
Yeah, good morning, madam. In fact, there is some problem. Madam, shall we start, madam?
Yes, sure.
Yeah. Today's resource person of our online 6 days program, which is ISTE-STTP on machine learning applications and research challenges. Today is the 6th day, first session. Resource person Dr. Jayapriya Kalyanakumar, who is the Director Research Associate in Solutions Tamil Nadu. Our Director Dr. C.V. Krishna garu. Our Coordinator Dr. K. Rameshwari garu, who is Head of the Department of our CSC department, and my dear participants and other all invitees. Very good morning to all of you. Warm welcome to our last day first session of our program. I really very happy that today's resource person have given kind consent to be a part of our program as resource person. That too with a very important topic, in fact, which is the order of the day, which is deep learning in computer vision. It's really a privilege from my side to introduce about Madam in a very short form. Madam has obtained PhD from Mother Teresa Women University, 30 plus research publications in her credit in highly indexed journals. The areas of interest of Madam are computer vision, machine learning and deep learning, data mining, natural language processing, and virtual reality. With this little bit introduction, I welcome Madam to start the session. Thank you, Madam. Over to you, Madam. Warm welcome.
Thank you, sir.
Madam, we made a co-host
Ah,
so that I think you can share the presentation, Madam.
yes. Very good morning to everyone. So, MLARC2020, that is machine learning applications and research and challenges. Actually, it is a national level short-term training program especially for machine learning. The program is successfully going on from November 2nd onwards. From the last 5 days, every participant got a very good knowledge, got a good clear idea about what is machine learning, what are the challenges in ML. I think in the first day itself, they give details regarding what is the support for machine learning in data science. And one more expert from the same field, they provide the details regarding data visualization. Parallelly, they also provide a base knowledge for Python, as well as the same resource persons provide a contribution regarding how we can use Python for supervised learning as well as unsupervised learning. I think from the WhatsApp group, I found out the screen. They also give an idea about what is regressions, how it's used for predictions, what are the different libraries that is supporting Python for machine learning. I think fourth day or third day, they given a introduction as well as exploration regarding deep learning, what is the difference between deep learning and machine learning, and so on. And they provide a network structures for deep neural network. I am just recalling the last previous day session. And what are the real-time application for the same criteria. So you got a clear view on what is the machine learning, what is the challenges, what are the real-time applications, what is the next step of machine learning, what is the part of the machine learning as the deep learning, what is the main difference, and so on. Today, my topic is how deep learning support for computer vision. I think there is no need to spend the time for these kinds of introduction slides because everyone got a clear idea about artificial intelligence and ML. So computer vision is also part of AI. That is, it is going to give a clear decision about the scene as well as the physical object in the scene with the help of learning algorithm, either it's a supervised, unsupervised, or whatever it may be. So normally you think computer vision is a visual recognition. You are giving a sensed image, that is from the camera or anything, hyperspectral image, what kind of sensed images, it will find some information. The basic thing is the image classification and object detection, image segmentation, from surveillance camera, how to track the object. And the main thing is how we can apply the mining with the image, computer vision, artificial intelligence to mine the image or video and provide some annotation for that one. Especially now, most of the people are using that face app, that is image transformation. That means we can transform the image from one image criteria to other criteria. For example, in this example, we are having this guy image. There is one lady. We can transform to some other stylish format. So all area, it is applied wherever visual information is needed. We are using the computer vision concept. Okay. During this pandemic period also, this area plays a vital role. For example, in computer vision, it support in the form of, first, it makes a decision regarding the social distance, whether the peoples are maintaining the social distance. The same computer vision is used in this medical images to make an analysis on the lungs, CT and X-ray image. And one more thing is the thermal detection. That is, using the thermal detection, they can find out which area the peoples are crowded. With the help of the thermal detection and computer detection, computer vision, they find out which persons are affected or not. This area also supported by the computer vision. And there is one Chennai-based company, Tamil Nadu Chennai-based company, provide a revision. That is, a company is provide a toolkit to find the violations during that period with the help of computer visions. And one more thing, that is to find out the vehicle, because everyone knew, we know what is meant by classification. In the classification itself, the vehicle may be a car or a truck or whatever, or some other vehicle. So in order to find out which one is emergency vehicle, to make the correct prediction, to make the correct traffic permission, for that also they use the computer vision. And hotspot zone detection is also done with the help of computer vision. So it plays a vital role in this pandemic period for the surveillance as well as in medical images. So I think you know what is deep learning. So we don't bother about it. Deep learning is different from machine learning. No. It is also a part of the machine learning, somewhat an extended format only we are going to use. So it has a lot of algorithms for learning purpose. So it, for example, in the previous session itself, it got an idea what is the neural network. I will show that also. So in the neural network, you may have some input and output. In between, you may have the hidden layers, 1 or 2. But in the deep learning, we are going to put multiple hierarchical layers to find the discriminative features from various aspects. So for deep learning, we have to provide information, lot of information to learn our input and predict what we want as our output. So this is the normal taxonomy. That is the main thing is the artificial intelligence. Artificial intelligence, you got idea about machine learning. Supervised, that is we need some training. We have to train. This is this one, this is this one. And such as we have to label the data. We have to train our system. when you give an input for sample data for testing purpose, based on the learning, it is going to make some classification or prediction. In the case of unsupervised learning, it is a automatic learning. Sometimes it may be semi and semi-supervised learning. In this case, we don't have any proper training data set. That is not correct. We don't not have the proper data set. That is, we don't want to train the data. It has to learn with the help of clustering. For example, autoencoder is available now. That is also one kind of unsupervised learning in deep learning session. So in deep learning, we are having two areas. That is, one is the neural network. Everything is based on the neural network format. Other one is, I already told that, autoencoder. Other kinds of methods are also available in deep learning. Normally, for computer visions, we use the convolutional network for the image analysis. Next one is the recurrent neural network that is specially designed for speech, that is a signal processing, as well as the NLP, text-based processing. It is a plays a vital role. There are a lot of things, LSTM by GRU, and so on. Everything is available under recurrent neural networks. So the same slide seen in the third day, I think. So in neural network, artificial neural network, we are going to give some input. So it's similar to our neuron. It will find out something. Either it may be, if you're taking the example of the image, either it may be color-based perspective or edge-based perspective or corner-based perspectives. In this way, it will learn through the hidden layer. Final layer is the output layer. This is the normal architecture for neural network. Then how it is differ in our deep learning means. So the first one is the normal learning and classification with the help of machine learning as well as neural network. That is, we are going to give an input. The features may be extracted automatically, or you can specify some label on the data. It will extract certain features, either it is a spatial features or frequency domain features or color, shape, texture features, whatever it may be. After the extracted those features that are classified with the help of, that is all classified with the help of the neural network shallow structures, we will get an output. But in our section, this deep learning, it is also doing the same thing. The feature extraction as well as classifications, everything is done with the end-to-end learning concept. So finally, it will produce the output. So the main basic is we have to give some certain data for the system for learning purpose. So, for example, I'm going to give some data. I'm having some data, for example, I'm having some data to classify the objects within the office. So I will put chairs and desktop and laptop and table and so on, everything. Each one I have to give the label, I have to train the system. So in the case of machine learning, it extracts the features. Those features are learned with the help of a support vector machine based on random forest, whatever it may be. So in this way, it will extract the features with the help of the extract the features, not with the SVM, extract the features either doing LPP, HOG, or wavelet transform. In the way, we will extract some features. After extracting the features, it will be classified with the help of support vector machines, random forest based on KNN, whatever KNN, K nearest classifier, and so on. But in our case, while I'm giving data with some sample as well as its corresponding to the corresponding label to the system, it will extract the features with the help of the neural network convolution layers. Okay, so it will extract the features and make a proper learning with the depth of layers. After that, based on the feature, that network will find out the correct class. That is, it will predict the data, either it is a chair or a table or a desktop or laptop and whatever it may be. Okay. So for example, I am feeding 1,000 records, 1,000 data for training purpose. Among the 1,000 records, I'm going to take for 800 records for training, 200 records for validation. Let us imagine like that. So based on the 800 records, it will extract the features with the help of the convolution layers. With the help of the softmax layer, it will find the correct classification. Not correct, it will find what is the actual classification results. So immediately it will check that remaining 20%, that is among 1,000, the remaining 200 data, it will make the decision. It will find out what is the answer. It will check with the ground truth data, how we got the accuracy, what is the loss in that. So if the loss is more, if the loss is not satisfied, depends upon our weight and bias, it automatically update the weight and bias value and back propagate the neural network, update those values. Once again, it will extract the features with the help of the new updated weight and bias, do the same process of predictions until the particular loss is reduced to the level. Or if you specify certain epochs, you want to train the system based on the epoch, based on the patch size, it will learn the system, it adjusts its weight and bias, it find the correct weights for each class. That will be useful for the next unlabeled data prediction. This is the actual basic principle of deep learning. Okay, so I already told we are going to give some input. So that input, we are applying some layers. Let us consider these are certain convolution layers in multiple layers in hierarchical format. Each layer has some strength to extract the features. I will explain it clearly in later slide. So after the end, all the layers are learned with the certain features. It will classify with the help of softmax layer, or they do the same bug until we reach a proper decision, proper goal. Those trained weights will be useful to predict the next unlabeled cat or dog data. So some filters, some convolution filters has the strength to extract the edges. Something will have the strength to the structure, that is particular parts of the images. Something to represent the actual abstraction level of your input. Next, what is the basic requirements for this deep learning basis? For example, I am working with only 100 data or 200 data. The data is not easily we can collect. In this case, the deep learning is not provided good results. Depends upon the data and the information about the data, because it needs a huge data set to learn deeply to provide a proper results. That is the main thing. If anyone research scholars, I'm doing a research in this area, medical image, for example, I'm doing cervical cancer, or other I'm doing some other different, apart from lung nodules, I want to, what is the interactive node between lungs and heart? In this case, I'm working, but I have only CT for 100 patients. Then it is not easy to, we can assist with the deep learning. So because it needs a number of data, and it fully depends upon the parameters. You cannot fix the same learning rate for all kinds of information. You cannot fix, if you come across the idea, the gradient descendant method, you cannot fix the same activation function for all things. You should have a proper measurable parameters, depends upon your data and the size of your data. We cannot easily run. That is, if you can use the recurrent neural network with the text-based, you are having 1,000, 2,000 data, means you can run with your normal laptop without graphics card, that is a CPU mode. But especially for computer vision and so on, you should have a system with the GPU assistance. So these are the main thing. You, before going to do your research, you are going to apply for something in deep learning, you should consider these parameters. These are the basic requirements. There are a lot of tools are available for this purpose. I will give a clear description each one, and next coming slides. So I don't want to spend the time. So these are the neural network come first, and then recurrent neural network. After that, they invent the CNN. Actually, CNN comes up to 1980, okay. But 98, I think after 2012, sorry, 2013 only, I'm using CNN. It's a long gap. It's 2013, 14, afterwards only, we are using CNN, but it comes 90 or 98. After that, deep belief network, that is also a very good one. We will see this AlexNet later. And 2014 itself, GAN evaluated, but now only it is a very good application for all the area. That is in the first second, I think second slides also image transformation. For image transformation, the main role is GAN. So now lot of transformers applications are also available in deep learning 2019 onwards. So it's gradually raised in the deep learning research community. Okay, I think already explained what it's doing. It's doing the same step, extracting the features. It will do the back propagation. That is the end-to-end learning. That is the design cycle of deep learning. Data, pre-processing, feature design, classification. This is the traditional one. Here, they collect the data, deep neural network. It also automatically extract the features. In the neural network, it will do the classification. That is the main difference. After that, only it comes to the evaluation. Hence, we got a very good accuracy compared to machine learning. But I cannot tell deep learning is best than machine learning. That is not suitable for all cases. Okay. In some cases, machine learning provides its strength. That is also another stream. So depends upon your goal and criteria and your research. You can fix whether it's a deep learning or a machine learning. Okay, that is I already told we cannot easily manage this deep learning algorithms, whether you are PyTorch and so on, with the help of CPU system. You should have the system with the graphics card. Recently, there is a one graphics card RTX 3090. It's the top rank in 2020. This one, NVIDIA GeForce RTX 2060 super graphics card only I am using here. Initially, we use the 940MX, then GTS Titanium. Now it comes to the RTX 2060. Depends upon the workload. I have to adjust the graphics card. We have to invest the amount for graphics card assisted laptop for fast running. If you are using on 940MX or GTX 1050, I think for the data image retrieval or for example, brain tumor blast data set. It for training purpose, it hardly takes around 8 to 12 hours. But if we upgrade the GPU from 12 hours, it will be reduced into 8 hours and 6 hours and so on. That is the main difference. And it won't have the space. It automatically provide an error message. We don't have as much of internal memory to update the graphics memory, cache memory to do the process. So this is also main requirement for deep learning. This is the deep neural network. You got a clear idea about DNN in the previous expert session itself. This is a normal convolution neural network. This is a recurrent neural network. I will explain it now. 1 minute. Okay. So this is an architecture for the neural network with the convolution layers. Normally in a neural network, we saw in the previous session, one input, hidden layers, and output. Here, now I'm concentrating some information regarding convolutional CNN. Okay, so we will give an input like this. It will divide the images. It will extract patches. The patch size may be for example, the image may be the size of 512 cross 512. I'm going to extract the patches. Depends upon the filter only. This window size will be varied. For example, I'm going to use for the convolution filter. The input size is considered 12 cross 12. Then it will extract 12 cross 12 sub window from the images. If it is a video, it will do the process for all the frames. Okay. So for each 12 cross 12 window, it is going to apply the filters what we specified. Initially, the filters coefficients will be randomly filled. The filter will be applied to the image. And the next, we are having some more layer, that is activation layer, the linear unit layer, and one more layer, pooling. So this is set, convolution, ReLU, and pooling. Once again, I am going to do convolution, ReLU, and pooling. Depends upon the filter size, it will be vary, depends upon the level. At last, we are going to make all the output in the vector format, flattened format. Then all the flattened formats is fed into the fully connected layer. That fully connected layer is going to used for to predict the to classify the object or for the segmentation purpose, whatever it may be. With the help of softmax layer only, we are going to classify whether we will get a score for car. For example, I am classifying the vehicle. What is the score for car and truck, van, and so on up to bicycle. So I will explain each one. Right. This will be useful. So let us consider this. The image is not in 5x5. Let us consider one image is there. My filter size is 5x5. Okay. But not filter size. My filter size is 3x3. For example, I am putting this slide. Let us consider the image size is 5x5. Your filter size is 3x3. What will it do? Filter size is 3x3. It take this filter applied into the first portion. Okay. Make it as a center portion. This one I'm showing in the mouse. It just to multiply the coefficient. So 1 into 1, we got 1. It's a simple example. 0 into 1, it will be 0. 1 into 1, we've got 1 here. So while applying the filter, I got the data like this and make the sum. For example, what is this? 1, 1, 1. How many ones are there in corner and center position? So corner 1, 1, center position, and this corner 1. So what will be the output? 4. So it will apply the filter into the image as each pixel as the center. First, it will take this area. Next, it will take the next pixel as the center portion and take next 3x3. So it depends upon the what the stride you specified. That is, stride means, for example, if I just omit the stride, this filter is applied first row to third row, first column to third column. Then it comes to the first row to third row, but second column to fourth column. If it is do each pixel onwards. If I put a stride as 2, so it take this area, it skip 2 and comes to this one. Okay, so it depends upon the stride value. The filter will applied into your image. So the basic simple example. After applying the filter into the image, we are applying the convolution filter. Okay, applying the filter into the image, we got an output that we call it as a picture map. Clear? So this is a normal working principle of filters. So I already told what is meant by stride. First, it will do this area. If I put the stride 2, it will take 3, 4, 5, 6, this area. It will jump on that. So why sometimes the stride is necessary? Because I don't want some redundant feature learning. You can use the stride. Then padding. Sometimes we need padding. What is meant by padding? Padding. For example, I'm going to apply the filter in this area. If it is a filter size is 3x3, I can take from the second column, not second column, second row, second column onwards, because there only we are having the top row and bottom row. So I want to include the corner. Border of the image means you have to specify according to the filter size. For example, if the filter size is 3x3, then you can make it as a padding as 1. If the filter size is 5x5, then you can make it as a padding as 2. Clear? So next layer is that is a relief layer. This is the activated not rectified linear unit. Why we are using this is, for example, suppose I am having applied the filter into the image. I got the feature map. That is common. We got something. Okay. So after getting that, I need some values necessary to clearly describe that image or that vision. So we have to fix some threshold. For example, I am fixing the threshold as 0. Then what it will do? It will take only the values above 0 from your feature map. Clear? So I think in the slide I put only relief, but there are a lot of linear activation. I will show in net. I will show that one. Apart from relief, you are having ELU, ELU, and then Gaussian ELU. Rectified linear itself, we are having the Gaussian ELU. Then one more thing, I think soft plex, soft plus. These are each one proposed. Initially, we use relief, but now I'm also doing designing a non-linearity in different form of exponential notations. So it will improve your results. So if you are doing a research with the help of CNN, you don't adapt everywhere relief. Okay, there are a lot of rectified, a lot of unit for non-linear operations. You find and search which one is suitable for your work. That is my tip for your work. And the next layer is the pooling layer. I think if you already know everything, sometime it will be boring, but okay. So what is meant by pooling layer? For example, I'm having the image, I applied the filter, I got output like this. Okay, but let us consider the sizes of 4 rows, 4 columns. The pooling is, I want to extract which feature is dominant, which is the average composition, which is the least. These are the norm and common operations, but you can do, you can write your own pooling. XOR based, you have to find something, or after getting the value, you can incorporate this value, you put a formula for this one and get a discriminate features. In this example, I'm showing what is meant by max pooling. Let us consider what is the size, 4 rows and 4 columns. I consider my pooling filter size is 2x2. So 2x2 means it will take 2x2 sub-blocks. Among the first 2x2, which one is maximum? 6 is maximum. So it take the value for the 6. Among this, which one is maximum? 8 is maximum. Okay, 8. Here 3 is maximum. Okay. Here 4 is maximum. Okay. So 4x4 is downscaled into 2x2 with the maximum value of each subsection. That is the maximum pooling. If you are using average pooling, it is going to find the average value for this one and make it as a thing. This is also very needed one. That is, you are reducing the size as well as you are preserving the information. That's why we are using the max pooling layer. Finally, the layer is the flatten. We have to flatten all the features. For example, you are applying convolution filters. 5x5 is the filter size. You are going to apply 16 filters. What is the output? For a single image, you got a 16 feature map. Okay. If you are applying the 64 filters for a single image, you got a 64 feature map in one layer section. Next, I am using 32 layers. What is the output? For each 64, you will get a 32. So the size will be enlarged. So at last, I have to combine into a flattened features. For that, we are using the fully connected layer. So this is a simple architecture. First, we are giving the image, applying the convolution filters. We are getting the feature map along with the reduce the pooling. It reduces the size. Once again, convolution RLU, feature map. Okay. Then fully connected. Last one is softmax layer. We are going to classify. What is this? For board, the score is 0.04. For house, it is a 0.05. While adding this, we should have value 0.1. The one will be divided into for each class. Okay. This is a work. I think the first day resource person, Mrs. Gina ma'am, my very good friend, best friend, and a technical oriented friend, especially telling. This work is we did in last year, I think. This is for the person re-identification. Why I am showing this? I completed the CNN. Okay. The CNN only we did this work. That is, in some cases, deep planning is providing good results. In some cases, it needs some handcrafted feature also. That is why I told, in all cases, deep planning only supports. It needs some support from handcrafted features. That is a normal, traditional feature extraction method. So here also, I am giving the image. This is the area of the person re-identification, not the person identification, person re-identification. That is that we have to identify the person in surveillance camera. The person may be captured in some other area, in a particular area. For example, A. The same person may be captured in some other area, such as B. It may be vary in the pose. It may be vary in scale, but it has to identify this person is that one. Okay. So that is person re-identification. Now you know what is this and this or so much. Okay. What is this? Convolution layer, max pooling layer, a ReLU layer. This architecture, simple architecture to extract the features from the person, not from the raw person image. Instead of that, what we did is, first we convert the image into HSV. So human perception view. Instead of using some cases, RGB is a dominant from prominent or in some cases, HSV will be provide the good strength. So first of all, the image will be converted into HSV conversion. So in HSV, you may got the huge saturation and value. I separate each channel HSV. At the same time, we make it as RGB. And one more operator is available. I think you know that one. SLITP, scale invariant local ternary pattern. It's one kind of texture feature extraction pattern. Here the color composition, here the texture composition. Okay. So what we did is, sorry. I'm applied the SLATP for the red channel, as well as here I take the H. I fusion this channel-wise fusion with the maximal method. After that, I got one image representation with the fusion of texture and color composition. We call it as the prominent chromatic texture features, I think, in the paper. That image is fed into CNN along with the raw image. That is the difference. This paper is, I think, published in a SCI journal, SCI indexed journal. Difference is, instead of supplying the raw image to CNN, along with the raw image, we find out the prominent texture feature image, so that I got a very good results compared to the previous deep learning alone method. So for example, Viper, it is a very challenging data set for the person re-identification. From this slide, you can find out why. What is the result? Well, whether they are getting the precision in rank 1.15 is okay. They are getting only 0.46. This is, I think, it's a IEEE journal. They are getting the result 0.46. But it is also a good result for person re-identification. In the case of face recognition, it will definitely give the result 0.9993 because of frontal view or whatever it may be. But person re-identification, some area may be not captured in the CCTV. So we got good results compared to the top 20 rank. 2% is also very good improvement in this area with the help of deep learning and handcrafted features. This is for one good idea. Sometimes handcrafted features also support along with deep learning. So now, in the previous slide, I just only show what is the layer we decide. This is a simple layer with the CNN only. There are a lot of predefined models are there. That is initially LeNet, AlexNet, VGGNet, GoogleNet, ResNet, DenseNet, SCNet, DLA. Lot of network is there. Initially, the last 2 years only, we use the predefined network. That is, we take the GoogleNet, we take, because at the time, I don't have a clear idea about the last, I think 2017 time, 2017, I used only the existing layer. At the time only, we are using deep learning, 2016, 17 only. Okay. So now we are also constructing different kind of layers in the based of attention mechanism. I will show later. So the layer construction is grooming. Depends upon the hierarchical structures, but the layers size will be small, but it is robust to extract the features. In this way, we are doing a lot of research, but this is the actual roadmap of layer network, CNN network, especially for image classification. This is one kind of architecture. The picture is not clearly shown, but you can write idea. Okay, here also they are what are doing? They are doing convolution and then a polling, a convolution. The filters is law, filters size is a length. This is designed in 1998. Okay, this is specially used for MIST data. Based on that only they proved, okay, this kind of architecture is better than artificial neural network. After that, they invented the VGG architectures. That is VGG itself, there are a lot of layers are there. VGG 16, VGG 19, and so on. Here VGG 16 is shown here. Here also, let us consider the input size is what? 224 class 224 class 3. That is a input architecture. Okay. So there we are going to use some filters. How many filters are there? First, they are using the filters, 64 filters, and then 128 filters. And then here filter size is not specified. Number of filters is shown here, 256 filter, 512 filters, and 14 cross 14, 512 filters. Last filter size is what? 7 cross 7. That is here 224 cross 224, 12. The size is reduced because this diagram represent convolution ReLU. The red color represent max pooling. The last blue color represent fully connected. The thing is, if you give an image to VGG, what is your feature vector size? 4096 features. Okay. Last one is softmax layers. Why here 1000 is in the basic architectures, they are classifying the image. For that image, there is 1000 labels, so that they provide the output class label as 1000. Okay. This is the architecture of VGG. This is one more architecture, that is the GoogleNet. This is also a old one now, okay, because we are designing lot of extended version of GoogleNet now. But how the path is here, only convolution, max poly, fully connected softmax. What they invented in Google Net, what is the difference is this one. That is, from each layer we got an output. Okay, so that output is once again fed into one convolution layer, then another pooling and convolution and so on. The difference is here, what they did is output of the layer is fed into 2 or 3 convolution layer, here 4 layers at the same time parallelly, so that it gives some improvement in feature extraction compared to other. Okay, that is a thing. That is the output of the previous, but now we are told this one as now we are having a lot of multi-scale, multi-hierarchical, deep dense hierarchical. 2019 and 2018, it is enlarged in different form. So the output of a previous layer is fed into 4 convolution layer. At the same time, all the features are concatenated and then fed into the next part. From the image itself, we can get an idea. It have a multiple level. Okay, this is a design in 2014. It's also play very well. It is also the predefined model. Next model is deep ResNet model. Slight difference. Okay, so what is the difference in this deep ResNet? The word itself tells it is deeper residual learning framework. That is, instead of hopping from every stacked layer, it do the stacked in different concept. I will tell this one. This architecture is, I think, ResNet 50. Okay, so what is this? This is 18, ResNet 18. The third column is ResNet 18, 34 layer, ResNet 34. This column is ResNet 50. For example, I'm going to give an input image. The first convolution filter size is 7x7. How many filters are there? 64 filters. It will give 64 feature map. After that, they are doing 3x3 max full with the stride true. Okay, we got some answer. After that, they are applying 64 filters with the filter size 1x1, 64 filters with the filter size 3x3, 456 filter with the filter size 1x1. How many times are they are doing? 3 times. So that they put the name deep ResNet. See this one, this green color. The set of 3, 1, 2, 3. That is the first 1x1 64 filters. Another one is 3x3 64 filters. Another one is 1x1 256 filter. That 3 section is repeated 3 times. Okay. Then 4 times they designed one particular structure. That is the next. Then 6 times they designed one compound structures. So how many filters are there? Totally here 3 into 64 into 64 into 256. That output is fed into 4 into 21 to 128 into 512. So that only they put the name deep ResNet. For this purpose only we are telling we should have the system with the GPU assisted. Then only we can run this kind of layers for the huge amount of 1,000, 10,000, 20,000 data. Okay. The architecture from this link itself, you can find out the architecture as well as the code for deep ResNet. Okay. Now out to this we saw what is CNN, what is CNN, what is the main basic idea for CNN. So a lot of frameworks are available for implementing this architectures. That is especially TensorFlow, Theona, Keras, Torch, and Coffee. Okay. Hello. Hello. Okay. Okay. These are the different frameworks available. I don't want to spend each because time is up to 11. Okay. I just give a clear little idea. TensorFlow is a very good one. This is developed with the help of C++. It's support in Python. Okay. But we are using TensorFlow here. It has some, that is, while using the TensorFlow, if you have a familiar knowledge in Python, then only you can easily adapt the TensorFlow, because each sentence have the different structures. So that is the thing. But that is one more thing is it is assisted only with the Python. That is also limitation of TensorFlow. Now the recent version is TensorFlow 2.0. It supports n number of utilities, lot of predefined net, lot of libraries available. If you are want to work in TensorFlow, now we are using Tensor, I think 1.14. Okay, but now we are changed into Tensor 2.0 for the recent papers. There's a one platform, and simplest platform is Keras. If you are a beginner, you don't have a very good knowledge in the Python and so on, means you can use the Keras for simple learning. But I will tell where we have to use each one. It also have some disadvantage. It is not suitable for high level coding. It is only constrained with the TensorFlow and the Keras independently it won't perform. Backend, you should have the Theano and TensorFlow or JNTU. Then only you can use the Keras. For example, one more thing, if you want to implement anything, okay, in deep learning means you have to install TensorFlow GPU version, not CPU version. You have to install TensorFlow GPU version. For TensorFlow GPU 1.14, you have to install Keras GPU 2.24. That is correlated. That is a main problem while using this kind of, because each each TensorFlow version support each kinds of Keras. Each PyTorch, there is a in the, I will show the link later. There is a in the Python PyTorch and I think CUDA, CUDN. You have to install your system CUDA. For example, if you are using the system NVIDIA or a Ryzen, whatever it may be, if it is a 1650 or 1050 means you have to install CUDA 10. If it is a previous version system graphics card means you have to install CUDA 9. If now I am here using RTX graphics card, so I install CUDA 10. So, and the CUDN library also you have to install. For CUDN, you have to install 7.4, I think, is 7.4. So depends upon the system configuration only. You have to install CUDA, CUDN, as well as TensorFlow version, corresponding Keras, corresponding libraries, and it is correlated. TensorFlow for this version, this Keras is suitable. For this TensorFlow, this torch is suitable. So you have to search, depends upon your work, depends upon your system configuration. You have to install properly, then only you can easily implement your code. PyTorch. Now, most of the work, now here we are using PyTorch only. It's a very good thing. It is easy to understand first it is easy to understand compared to TensorFlow. It is a big competitor for TensorFlow, because if in my situation also, I have some code, GitHub, there are a lot of codes for all deep learning frameworks, okay? So I got a code in TensorFlow. I can understand, but I cannot give fully fed my knowledge to the scholars. They have some difficulty to modify the data. So I will change the TensorFlow code into, I will make all the code into PyTorch, because it is easy to understand. The scholars also easy to manage that code. They can also extend the code. PyTorch is a very good thing for learning purpose. If you are a beginner in deep learning, if you want to implement, means you can learn with the Keras, you implement with PyTorch. That is my advice. It's not, I don't know whether it is okay or not. My advice. Okay. So some people have a very, I forgot to put one slide. That is a MATLAB. I fully last 20 years, I am doing all the works in MATLAB. But last 7 years, 6 years only due to the deep learning, I just say I don't install MATLAB, because, but MATLAB has a very good environment for some other process. MATLAB also supports deep learning, because in our cases also, some researchers we are doing MATLAB. For example, especially in hyperspectral images, we are doing with the help of MATLAB. Depends upon some medical images. For transform-based images, we are doing deep learning with the help of MATLAB. But in Python or PyTorch, we are having plenty of libraries. That is the difference. And MATLAB also, I think MATLAB version 2019, we are having the deep view architecture, easy to design the layer. We can drag and drop the layer, we can design. There is no need to write the code. I can drag and drop. I put a max pool, then average pool. I put a multiple hierarchical structures. I develop a concatenation layer, and so on and so on. It automatically generates the code. So it is easy to check whether it is working properly or not. You can also use PyTorch. It has a lot of strength. I already told now. One more thing is copy. It is also very good, but this is fully implemented in C++. It is difficult to learn, but it is useful for CNN and feed forward. Now Coffee 2 is available, that is supported for the mobile based. TensorFlow also, one more thing is available. You may go and search TensorFlow Lite. and TensorFlow JP. That is a Java-based net node. You can use that one. And TensorFlow Lite, specially designed for mobile-based application. Coffee 2 also support mobile-based application. Now, Coffee 2 is merged with the PyTorch 1 version to combine the strength of both. So, you have to check which one is suitable for you. If you're familiar with the C++, you are C++ structure, you can use TensorFlow. You are having a little bit knowledge in Python, you can use Keras. You have Lua and C and CUDA writing coding. Very much you know, you can use that. That is the difference thing. Everything is different in the syntax and all thing. Okay, Coffee is a full C++ and Python, and it's also have a very good interface for MATLAB. While using the MATLAB, I always depend this Coffee toolbar. But now Theano is we just omit the Theano. Last 2 years we didn't think about Theano. Once PyTorch arrived, we are using PyTorch for a lot of area. The beginning stage only we use the Keras. Okay, so depends upon, if you are PhD students, you have to use TensorFlow and Torch. That will be useful. If you want to use a DL, how is working, you want to learn, then you can use Keras. If you are doing industrial project, the TensorFlow is very much needed. So depends upon your working environment. You can decide which you want to learn first for deep learning. If you don't, even know the Python, but in the previous session itself, we got NumPy, Matplotlib, Pandas, and so on. So you had some idea about Python. So at the time, you can use Keras and Torch. Okay, I will give a simple program for this convolution neural network, right? This screen is audible. So, sorry, screen is visible. The letters are visible. Yes. The coding window is visible.
No, could you please increase
some font size? Okay.
Yes,
that's only I'm asking. Now.
Little bit, ma'am.
Okay. Now. Why?
No, ma'am.
Okay.
Can you please zoom it, ma'am?
Okay, I think the slide is only viewing, but I changed the spider window. I opened the spider window. Okay, I stopped that screen and share this one. Okay, wait.
Okay, ma'am.
Share the screen. Where is the spider? Okay. Share. Now?
Yeah, it is visible, ma'am.
Okay. I think this is enough.
Yes.
Yes?
Yes, ma'am.
Yes, ma'am.
Okay. I don't want to spend this commands I import, because already in the previous class itself, you have to import NumPy. I am using the code Keras. I already told we cannot easily run the program in Keras. It also depends upon the backend asset and TensorFlow, and so on. I import the Keras, I import the layers. Okay. So in this example, we are having only 10 classes. This is I will explain it quickly. So we are having only 10 classes. The class label is 10. Our input size image is 28 class 28. That is the handwritten characters. Okay, MNST data. So it's the size 28 class 28. It's a grayscale image. So the channel is 1. Okay. So Keras data sets, because I don't give an example for the very big work, I want to explain how to write the layer. For that purpose only, I am explaining this code. So in the Keras data itself, we can download the MNIST data. So the data will be downloaded. Xtrain is our training data, and the corresponding label is white-train. Xtest is our testing data, and corresponding label in white-test. Okay. So what we will do, normally in some cases, we need to change the data for normalization. That is, we have to change the scale into particular range. Here, everything in a grayscale, it will be the range from 0 to 255. So each value is divided by 255. So range will be, I come to the range, sorry, the value of the intensity is come to the range 0 to 1. So Xtrain is a training data, Xtest is a test data. Okay. Then what I am doing this is the shape, the image size. While applying the data for deep learning, it will take the first channel. If it is a color image, red, green, blue. Okay, normally. So image sizes, let us consider 128 cross 128, then 128, 128, 3. Channel is in the last mode. Sometimes in some cases in PyTorch, I have to make the channel as the first mode. For example, I am using PyTorch, I am training 100 images. So what is the input size of my training data is first dimension is 100, that is 100 images. Color images, second dimension is 3, that is number of channels. Image size is 128, 128. Then third and fourth dimension will be 128 cross 128. So this example is also available in the net itself. So I just change the size, expand the size, and we print the size of the training and print the size of the test sample. That is not necessary. Okay. Then what is this is, while training your data, our class number of classes is what? 10. So how many class labels are there? 1, 2, 3, 4, up to 10. Okay. So we have to make it as a categorical value. We have to change into a categorical format. What is meant by categorical means? For example, if it is a first class, how many classes are there? 10. So first column will be 1. Remaining zeros are, the remaining 9s are filled with 0. For second class, the label is what? 0180, 001. That is a categorical form only. We can give input for the training, so that we make it as the categorical value. What we are going to make there? Class label. Number of classes is 10. Categorical. This is the tested training data. Ytrain is the class label for the training data. Ytest is the categorical form of the class label for the test data. Okay. So it's a very easy while you want to implement the normal CNN or in-depth CNN, whatever it may be, with the help of TensorFlow, Keras models. Okay. So first one, we have to import the sequential, because we are going to consider the sequential layer. So import that one. What kind of layers you want? For example, I want convolution layer. I have to use conv2D, and max pooling layer, flatten layer, dense layer, and dropout layer. What is this dropout layer? Sometimes there may be a redundant features is extracted. So in this case, there is no need to have the over over 50. Okay. So we can reduce those features with the help of this dropout layer. Okay. So now I am going to design a layer. First of all, there is no need. Python is a very good, there are all kinds of open source. There is no need to declare anything. We can just give a variable. I am giving model. This is not compulsory. You can give mm equal to sequential. That is for a meaningful purpose. We have to understand. So I put a name as model equal to sequential. Okay. What is the next statement? In the model, I want to add a layer. Which layer I want to add? Convolution 2D layer. What we already saw. So I want to add a convolution 2D layer. How many filters I need? Sorry. How many filters? 28 filters. What is the filter size? Kernel size equal to 3 cross 3. What is your input? My input size is what? Image size is what? 28 cross 28, because it's a digits. Okay. So first layer is input layer. First layer is the input layer. That input is given as the input for the layer. Which layer? Convolution 2D layer with the 28 filters with the filter size 3 cross 3. So we got some output. That output will be, once again, I want to feed into another layer. What is that? Max pooling layer. Here the pool size is what? 2 cross 2. Simple convolution, max pool. Here I don't put the ReLU layer here. Once max pooling is done, I am flattening the 2D array into a fully vector size. After that, I am going to apply the activation function. This is the activation, hidden neuron units. How much output I want? 128 output. So I am giving 28 cross 28 image. Okay. So I applied 28 filters, then max pooling. From that, I am going to extract 128 features with the non-linearity activation function ReLU. So what is your feature size? 128. Because that is enough, because the image size is 28 cross 28. So after getting the features, I don't want to, so I want to make a random dropout. How many percentage? 20, how much percentage? 20%. Okay. What is this? This is the last layer. That is the classification layer. So here the classification layer is what? Softmax. How many classes are there? 10 classes, because 10 digits, 0, 1, 2, 3, up to 9, we are having 10 classes. So I put 10. So what is this? It represents how many class it has to predict. Here 10 classes, so we put model.add of dense of 10 comma activation is equal to softmax. Clear? So I design a layer. Simple example, design a layer. I want to compile it. I have to put model.compile. Okay. I already told what deep learning will do. It will get the input. It will extract the features. Based on the feature, it will classify and find out the loss. If it is not okay, it will go and update the weight and bias. Okay, that we are having the two parameters that is a very important for any kinds of neural network. One is the loss, another one is the optimizer. Okay, if you have, I think in the previous session classes itself, you got a gradient descendant. What is the gradient descendant? How to go, which one is our path, which we have to decide, how to vary the values of each one. For that, we are having a lot of optimizer. Adam is there, stochastic gradient descendant is there, RMS prop is there, lot of optimizers are available. But you have to choose which optimizer is suitable for your work. Which loss function, entropy loss, a mean square loss, categorical cross entropy loss, lot of losses are available, which is suitable for your data. How to put the parameters. This I already told, depends upon the parameter, it will be vary. What metrics I want to evaluate? This is a simple example. I want to evaluate only accuracy. What is meant by patch sizes? For example, it has the 10,000 images, 1,000 images. So each time, how many images it has to use for learning? Now the patch size is 128 because to run quickly. But if you are having a 10,000 data or 20,000 data, you may raise the patch value. Patch size you have to raise. If you raise the patch size, it will learn from lot of data. So definitely you can get a significant result improvement. Okay. So if you are using the keras, how to train the data? Just a simple model.fit. It will vary. TensorFlow, the syntax will be vary, but working nature is same. Model.fit. First argument is your training data. Second argument is the class label for your training data. Third argument is how many patches it has to learn for each iteration. For example, I am having 1,000 data. So patch size is 200. Then how it will do? Among the 1,000, it randomly pick 200 patches. It learn. For the first epoch itself, it will do 5 iterations. Per epoch, I am having 1,000 data. Patch size is 200. So among 1,000, 200 data, 5 times, 5 iterations for a single epoch. Okay. So now the patch size is 128. Epoch I just given only one epoch. What is this validation split? What is among the 1,000 data, 10% I am used for validation purpose. Okay. So this statement, this is a single statement to learn your data. Okay. After end of the learning, what we will do? I am going to test my data. For that, which is the what is the command? Model.evaluate. The first is which data you want to test. Which is our data? X-train is our training data. X-test is our testing data. So I am giving X-test, comma. I want to predict as well as at the time itself it has to evaluate whether it is correctly classified the digits or not. So that only I am using model.evaluate. Okay, there is one more thing, that is model.predict means it only predict what is this, whether it is a 0 or 1 or 2. Model.evaluate means it predict at the time it will find out its accuracy and loss. Okay, so that only I am sending the ground truth data also. So we got the score. In score, we are having the two output argument. Score of 0 is the loss. Score of 1 is its accuracy. I don't want the evaluation. I want only prediction. After that, I am going to estimate other parameters. Means you have to use this command model.predict. Just to give the test data, it will predict the answer. What will be the prediction? There are 10 classes. Okay. So for example, the first input, you will get the first test data. For example, the first digit is 8. It will give a 10 output. For it will be the score. For what is the score for 0? What is the score for 1? What is the score for 2? And so on. So for example, the score in 8 may be 0.7. So which one is highest? In the column, 8th column. If it is a 0 to 8 means the column is 9. Okay. 9th column, the value is 0.7. Okay. Which column have the maximum value? Corresponding label is its predicted. Okay. So after predicting this, I want to evaluate. Here I got only the accuracy. You want the precision, recall, FN score, and so on. Then I have to use this sklearn. You have to import the metrics. Okay, I'm going to give a predictor label array. How many records are there in X-test? And this for that size, I'm going to arrange array with the same size. I'm going to fetch each value because the predict, for example, we are predicting 200 data. We got output for the 200 data. I put a loop here. I'm going to take which are the column in the column, which one is the maximum. Based on the maximum, I will extract the predicted label. This loop is repeated for the 200 data. After that, I already taken the value, weight test. Before converting into categorical value, I put the weight test value in weight test org. That is our ground truth label. So I'm going to give the ground truth variable as well as of the predictor label as the second argument. I'm going to evaluate our accuracy. I'm going to evaluate of the precision, recall, and the FN score. I can run this program, but it will take some time. Okay, you can just run this program. But I got the screen and put it in the PPT because here also the data is somewhat something 1000, I think, but it also take time. Okay, it will. Okay, I will show in the slide itself. I got an idea. Okay, I will stop this one because it will take time. Where is the PPT? This. Okay, that the code, while running this code, see, running. Epoch 1 is running. Okay, training sample is how many are there? 54,000. Testing samples are 6,000. Clear? So for I am putting only one epoch to run it quickly. For the first epoch, it run. The loss is 0.287, accuracy is 0.91, validation loss is 0.0937, validation accuracy is 0.97, 97.48. Okay. So after that, using this command, this commands, I find out what is the precision, recall, and FN score. Actually, instead of using machine learning algorithm for this MINST data with a simple layer architecture, we are getting the results up to FN score 96. That is the difference. Clear? Now you got some idea about how to design a simple layer with the help of Keras. Okay. So now I think I used a simple layer. If you want to use VGG16, VGG19 for your work means from this site itself, keras.io.api applications, you are having a lot of available model. There is no need to write the code for VGG60 and VGG19. You go to this site. They provide how to use this one. For this, we put the code like this. That's the same thing. For example, TensorFlow keras.application, you have to use VGG16, import VGG16. That is enough. There is no need to design as much of layer for VGG16. Clear? So you just import from Keras. This is not only in Keras. PyTorch also we are having for all predefined model. They put in the predefined nature. You just import which network model you want. But you don't use the model as it is. You have to change. That is for one kind of idea only they are providing. You have to change the layer architecture of VGG16. You can also combine different layer in different format. Then you can use it for your research purpose. But you can check whether your proposed layer is better than VGG16. For that, there is no need to write the code. You just import VGG16 like this. This line, 30th line. VGG16 weights, here we are using the weights of, because ImageNet, if you want to train ImageNet, it's a billions of images, okay? If you want to train ImageNet with the VGG16, it hardly takes 5 days or 4 days, depends upon your system. So they already trained the data. They provide the weights. In the previous program, we trained the data. Clear? We developed a single layer. We trained our data. We trained the data. Based on the weights, we classified. But in VGG16, they already made a clear training on ImageNet. So I don't want any training. The ImageNet is for images, different types of images, cat, dog, person, cycle, car. There are 10,000 categories or 1,000 categories are there. Okay, 1,000 categories. Because in the architecture, I saw the last layer as a softmax layer, 1,000. So 1,000 categories of images are available in ImageNet. The thing is just like model equal to VGG16 within the brackets, which weight you want, whether you want cocoa weight or one more thing is Volo, we will see next. So based on this, you can use the weights and include top equal to false. That means I'm just going to use VGG16 as it is. I'm not going to change any layer architecture. And in that case, you have to give include top equal to false. Okay, in my folder itself, there is a one images doc JPG is available. So I put the image past the doc JPG. I load the image with the image pre-processing image import. I already imported image.load. I load the doc JPG image. I make it as a array format, and then it's already I told I have to change the expand the dimension. We pre-processing, that is, it will do the normalization process. It just give the sentence model.predict of x. It will predict the score. Okay, how many scores will be there? Because 1000 images. So how many scores will be there? 1000 scores will be written. If you want the top score, I have to write like this. In the previous code, I put the like, you have to choose the maximum on that score. Okay, I want top 3 rank. So I can like write like this. Decode underscore predictions of, what is this? Predicts, we got the results, top equal to 3. While running this program, if you are running this program initially, it will download the weight, ImageNet weights from the net. It will download the VGG16 model from the net. It will take some time. Well, first, it will download the data. After that, only it give the results. If time permits, I will show. But you can use like this. Okay. If instead of VGG16, you can also use GoogleNet, AlexNet, and so on. I already told include top. Whether you want to include the fully connected layers at the top of the network as it is or not. If you don't want to change, means you have to specify false. If you want to change, you have to specify as true. Okay, this is a torch. For torch also, you can get a clear idea. If you just type PyTorch documentation, torch vision models, it comes into this site. From this site, you can get all the model. What I already shown in the slide: AlexNet, VGGNet, ResNet, and one more thing, DenseNet. This is the variations of GoogleNet, Inspection V3 model, and MobileNet. We are using a lot of work MobileNet now, and ResNets. Lot of nets are there. One net is available for Retina net, that is not specified here. So these are the predefined model. You just go and see what is its a layer architecture. How many layers are there? What are the special thing they changed compared to the previous one? Okay. Based on that, you download your data. Download your model which you want. Okay. So in this way, you can download the pre-trained model. So this is a code, whether it's viewable. Okay, viewable. What is this? So instead of using the Keras layer, I want to use everything in a torch vision. 1 minute. Okay, if you want to use, instead of Keras, I want to use torch vision models, means you just type. But I already told you should install TensorFlow GPU 1.1414 and the torch version 1.04. This way, you should install the torch. After that, you can use the torch version model. So import torch vision model as models. I want to use ResNet, you just give ResNet 18 equal to model start ResNet 18. I want to use ResNet 50. I already shown in the slide ResNet 50, this one. So ResNet, this is a ResNet extension 50. So you have to use a ResNet 50, 34 inted. It involves some difference. Okay. So I want to use VGG16. You can just give VGG16 equal to models dot VGG16. That is enough. In this way, you can import your model. You can write your code. Okay. So now we saw something about classification. Next thing is semantic segmentation. I want to segment this image, this man, this is the bike, this is the background, and so on. What is the difference here? Semantic segmentation is pixel-based segmentation. Each pixel has to classify. In the case of previous case, whole image is labeled as one class. But in this image, 3 classes, man, bike, background. So each pixel have the classes, 3 classes, either man or bike or background. That we call it as a semantic segmentation. I don't want to spend the time for explaining this one. This is enough. That is segmentation. But segmentation, semantic segmentation. We have to fix label for each pixel. How we can do? The basic segmentation layer is fully connected neural network. That is, we have to give the input image. See this one, what is this? Convolution, max pooling, ReLU, downsample, max pooling, convolution, ReLU, max pooling. Okay. Fully connected. That's all. Up to this classification is enough. What is the segmentation? For each pixel, I want 2 classes. Okay. Then we have to reconstruct how you downsample the data. The same way you have to upsample the data. So up to this, we saw only convolution layer for segmentation, semantic segmentation. Either it may be natural images, either it may be medical images or hyperspectral images. One more thing is that is deconvolution layer. We have to reconstruct the output as the size of the image. Clear? So for VGG architecture, I will give, say this one, already we saw this one. Okay, 7x7, 4096 features. Okay, this is the flat 10. Actually, 7, what is the output? 7 into 7, how many classes are there? Once again, I have to upscale. How we can upscale? We are making it 7 into 7 into 14 into 14. Then how we downsample? 224 into 112, 28, 14, 7. The same way, I have to deconvolution process 7 into 7, 14 into 14, 28 into 28, and 112 into 112. Final answer is 112 into 112. Then, based on the interpolations or pixel transformation, I have to reconstruct into our original image size. What is our size? 224 classes. Here 224 classes are GB. Here, how many classes are there in the previous slides? Byte, man, background. So what is the output? 224 class 3. So that is each pixel has the 3 score. What is the score for man? What is the score for byte? What is the score for background? This is the first simple example only I'm telling. Okay. This is one more paper we did in the same on one journal. That is melanoma cancer detection. For that, what we are using VGG16 and fully connected Google Net. Using the semantic segmentation, we will find the score for each pixels. For each pixel, it will produce some score here. It will produce some source here. Here we make a score level fusion. From the whole image, we segmented the lesson. Okay. Then I have to classify whether the lesson is a malignant and benign. Okay. So for that, we are using one deep recurrent neural network with the size of 50. That is the one kind of recurrent neural network. The initial stage, I don't have idea how to change the layer structure and so on. Now we are doing a lot of new layer architecture in the same cancer, person re-identification, hyperspectral, and a lot of medical images. Here also we use one handcrafted features along with the support of deep learning and handcrafted features. We extract the features. Here I don't use the softmax layer because we instead of using softmax layer while using the normal ML. So that only I told in some work we need deep learning. This area is what? Semantic segmentation. Okay. This area what? Feature extraction. This is for classification. I am using the support vector machine classifier instead of the deep learning classifier. We are getting a good results for this work. This is an idea only. Unit architecture. I will give a small example for the semantic segmentation also, how you have to write the code. Unit is a very basic architecture for medical image segmentations, especially designed for lungs, brain, and abdomen medical image segmentation. The thing is, I already told how you convolute the same way you have to deconvolution. While deconvolution, for example, this is a flatten, I'm upsampling, downsampling, upsampling. That is convolution, deconvolution. I need support from the same downsample data. We have to concatenate the data. You have to upload. From this layer, it got some output. That output is concatenate with the previous convolution downsample data and produce the deconvolution. The structure is U, so it is called unit architecture. Now, one more architecture is the VNet. The structure is like in view. One more architecture is the unit with the mobile unit with the mobile net. It has the strengths of unit as well as mobile net. We are using the instead of using unit, I am using that one for further process. Okay. So for this also, we are also have the code. Time permit, I will share that one. So, and let's see. Okay. So in this folder, I am having the thyroid folder. There we are having the images. This is in the Python folder, so it won't show the images. Okay. So I'm having the thyroid ultrasound images. Okay. So for each images, I have the ground truth. Now we are seeing the semantic segmentation. What is this? For the first image, where is that nodule is available? The label with the 1 is the nodule area. Label with the 0 is the normal area. Okay. So here we have to label like this. You should have images as well as it's a corresponding label in some other folder in the ground truth. Clear? So now I am going to open the code. Demo unit. Control plus. Okay. The same conv 2D max 2D. What is this? How you do the convolution 2D? The same convolution 2D upsampling. That is the difference. Okay. So normally in segmentation, what is the actual parameter? Dice coefficient, intersection, dice coefficient loss. For that each one we write the function. This is the unit architecture. What I already see shown in the PPT. 250 crash 240. It's maybe a color image, whatever it may be. Convolution, max pooling, downsampling. This area is downsampling. Then conv 2D transpose is the upsampling. Conv 2D transpose is the upsampling. So for example, I'm going to concatenate this is a structure. See, I'm going to concatenate. What I am going to concatenate? What I got in conv 5. What I got in conv 5, that is fed in the input for the upsampling, which will be concatenate to the previous layer. See, conv 4, what is the size? 256 class 256. Okay, 3 class 3 filter. I got some output. That output I fed once again. I downsampled with the max pooling. That is for the conv 5. That is conv 2D. We got some output. This output has to be made into upsample to the size of this one. What we got in conv 4. So that only we first transpose the what is the output of conv 5 with the conv 2D transpose. Then it is concatenate with the conv 4 in axis 3. Third dimensional wise, it's concatenate. So we got the results. Once again, it do the same convolution, concatenate, transpose. So we got the upsample. The layer only vary compared to the previous one. Here we use two different concepts, that is conv 2D transpose and proper concatenate architecture. So we will got the full model. Okay. So what is our input? Input equal to inputs. Here I am using the Adam. Already in the previous example also, I think Adam, we can also use the SGD. Learning rate, it clearly depends upon the learning rate. Now the learning rate is 0.401. Here the loss is other classification. So I put the loss as crash entropy loss. But here what is it? Semantic segmentation. So each pixel has to be predict what is it as. Okay, so the loss will be depends upon the dice coefficient. You go and see what is the dice coefficient. How many pixels are correctly predicted? Okay, with the help of intersection of true and ground truth and the predicted results. So loss is dice coefficient loss. Matrix is what? Dice coefficient. I print the model summary. Okay, the thing is here class label is not like that 1, 2, 3. Here the class label is a ground truth. So our train data is what? The images which are under the folder thyroid. For the label data is what? Ground truth I specified under the folder thyroid. Okay, so TR data is the train data. TR mask is the your ground truth. So I make it as an array format. I already informed that is number of samples, number of images should be in the first channel. Then what is that? Height, width, and number of channels. In this way, you have to arrange the ground truth data as well as your image data. Clear? The same command what we done in the previous example, model.fit. But before that, I'm going to split the training data. I'm going to split the training data as 70% for training, 30% for testing. In this way, it split the data. So X-train is your training data. X-test is the corresponding ground truth mask for the training data. Y-train is a, X-train is the training data. X-test is the testing data. Y-train is the mask for the ground truth data. Y-test is the mask of the testing data. The same thing, model.fit. What we have to give here? training data and the corresponding label. That is a mask. Here I put the batch size as a 1 and epoch as 10. I have to run this program. So it will train the unit architecture. It will predict the other. It will provide the results in the output image folder. If you train the system, you can save the model with the help of model to JSON. Okay, model to JSON, you can write your train the weight as well as model. So there is no need to train once again. For that, we have to use what? Model to JSON, JSON file dot write model to JSON. What I want to write? I want to write this model as first thing. Okay, then I want to save the weights of the learning methodology. For that, you have to use model dot save weights with the format of extension H5 format. It will save in the hard disk. So you can use it for some other cases. There is no need to train the same data for 10 epochs and lot of time consuming process. Okay. So in this way, you can write the code for your semantic segmentations. This is a simple example only I'm telling. The same thing you can easily develop with the help of the PyTorch also. If you are beginners, you can learn with the Keras. You can also easily learn with the PyTorch. It's a very simple to learn. Okay. Let's stop this. So you got the output like this while running this program, because it will take time. So that I come to the slide so itself. For example, see, I'm putting the number of epochs is what? 10. First epoch is a run. After the first epoch run, I got the loss dice coefficient as 89%, loss as a 0.893 minus. Okay. Then as the second epoch, we got the results for 0.99. And one more thing, you don't think, okay, we got 99 results for this data. So it's okay. It's not good, because training time validation accuracy will be vary for the testing. If you want to give some other data, the value will be varied. So you have to find out training time accuracy. You have to find the validation accuracy. After that, the data which is not already used for validation and training, you have to give some unlabeled data. Find out how much you got the dice coefficients and Jacquard distance and IOU. Those are the segmentation parameters. Okay. The last one, that's not last. I just omit this because I think you now got an idea about classification and the semantic segmentation in computer vision. What is this? Object detection. That is, we have to detect an object. So if you are working in the area of object detection, you definitely know what is RCNN, what is fast RCNN, what is a different, that is a region-based convolution network. Fast RCN means some problem, that is, it won't do the process very quickly. In order to make it as some fastest arrangement, they provide some region-based architecture deviation from the normal RCN. That is what is it? They are using the deep convolution net also. The same time, RVA projection is also given as an input. So using the deep convolution and RVA projection, I got some feature map. Then already what I explained, max pooling, average pooling, and so on. Okay. Here the difference is, instead of taking all the area, it only do the pooling in the region of interest. That is the main difference. So we call it as a ROI pooling layer. Clear? The same procedure, same thing. After ROI pooling, they will make it as a fully connected layer and use the softmax layer. Along with this, one more thing is added. That fully connected layer is fed into the softmax layer as well as the fully connected layer fed into the bounding box regressor, because it has to find whether it is properly the ROI region is founded, whether there is any changes in the boundary part. That is only fast RCN is somewhat better than normal RCN. I think in the slide itself, one more thing I put, that is corner net. That is a recent one for object detection. The same thing, softmax, BB box, and they also find out the something important regarding the corner. That is a 2019 papers. They provide a new architecture for object detection. So Volo is a common one. You only look once. It's a common thing they are using. You can easily, I already told now. You can download the predefined version for Keras and PyTorch. PyTorch itself, it is a predefined version for Volo. Using that, you can use and detect your object. If you want to make it as a train, you download the architecture. You made some changes. You have to train customizely, because it only give what they trained for the 1000 category. But some objects, it won't be in that trained data, means You have to train your data. You have to, after that only, you have to classify your required data. Okay. So for this also, I put the code there. I don't want to explain each line. So see, if you want to use Volo, from the net itself, you can get its layer architectures. You download this one. You have to download this. Just type that, it automatically get you to the GitHub page. You have to download this Volo V3. If you want to use Volo V3, you have to use this weight. If you want to Volo V2, you have to download Volo V2. And one more, this is Volo Tiny. Okay. So in Cocoa datasets, I think already it's 1,000 categories. So so that only I told, if you want to train your new objects, you download the Volo structure only. Don't download the weights. You download the structure, you train your data along with the Cocoa. The page itself, they specify how to train your customized data. So based on, you can train your customized data. So darknet, this is a predefined developed class for this Volo. So model, you have to type like this, darknet, then config path where we are having the Volo V3 configuration. You have to specify your image size and model.load weights. In the previous example, I told, you have, once you train for unit, you can save your model, you can save your weight. So once you train your model, you saved your weight. Suppose in some other system, I want to segment a thyroid image. So there is no need to train the unit. You just load the weight by this command. Model.weight, your weight. What in under which folder and under which name you save the weight. You just load. One more thing, it is run in GPU mode only because it will take the time. So that I make it as a instead of running in CPU mode, I make it as a running in a GPU mode. You have to give model.CUDA. Then model.eval, it has to evaluate the model. So it automatically load the classes. So once I run this program, it will take the things. Here I have to specify the which image I want to find the object. This simple command is enough. Detect image of IMG detection. So it will comes to this area. This will transform the image into the, it will make the image at the scale in padded size. Okay. Then it converted into the tensor because I am running in CUDA mode. I convert the NumPy array into tensor. After the tensor variable tensor, we can view that image, tensor formatted image to the model. That is simple line, model of your image, which is adjusted into cropping, which is converted into tensor and give it to the input for the model. It will predict the results. It will detect the objects and it's a boundary. So I make it as the threshold. Which are the objects as the confident threshold I already specified. Threshold is 80%. If it is a car, it should be more than 80%. That is root means NMS threshold and confident threshold. Based on the threshold, it find out the object and put the boundary. If I run the program, definitely it will take that time. So this is the way you can use Volo in your system. There is also one separate code along with this one in GitHub itself, how to use Volo V3 for object detection as well as video object tracking. Clear? Yeah, just will take some time. Okay. This is a new one thing, single shot detector. This is specially designed for mobile-based application layer architecture. I already told corner net. This is also 2018. They also make some changes in corner along with the, apart from fast RCN, they make a changes in top left corners as well as bottom right corner. They define the previous one ROE pooling. They profile a design so that only initially I told you don't concentrate on layer architecture. You concentrate on your work research area, how to change the pooling. It is a very good. This is also very good paper. They provide a new pooling architecture that is a corner pooling. The simply I will tell attention mechanism. The computer vision, the attention mechanism is a very important one. That is, up to this we saw, we are doing some convolution, we are doing object detection, segmentation, and so on. Which area I have to focus? If I saw an image, sometime which one is catchy, That area only I will watch. So in this way, you can make some attention mechanism. The attention mechanism may be two way. That is a spatial attention. Spatial attention means position based attention. Which area it has to focus. Okay. And one more thing, channel attention. Which channel we have to focus. So for that also we have different architecture. That is channel attention means it will take the pooling based. Spatial attention means it will do the position based pooling. So this is also very good. You have to include this concept for your computer vision program. The last one, I'm going to finish with this one. I think the time is over. GAN.
Yeah.
You can adapt this GAN for your future work. I will simply tell this one. I just get this one. Okay. So GAN, you will give a sample for the architecture. Okay, this is a given sample. There is a two things. One is generator, another one is discriminator. Okay, this is the real world sample. Generator will do, it generates some sample. For example, I want to generate some fruits. It will randomly generate some fruit structure. Okay, so that is this one, G of Z. This is the original fruit. It will check whether this apple, generated apple, is matched with the original apple with the help of discriminator. It can identify whether it is a fake or real. If it is easily identify means it once again instruct the generator do the same process. Up to the discriminator cannot differentiate which one is real, which one is fake. So using this only, we are doing lot of works in image. While doing the discriminator work, generator will stop. Generator doing the work, discriminator will be locked. In this way, instead of back propagation, here there is a relationship between the generator and discriminator. This is a basic architecture for the GAN. It is developed in lot of waves. Okay, the conditional GAN and adversarial GAN. From this link, you can find out, because I don't have the time. So from this link, you can find the code for GAN generation with the help of torch. It's a very simple code for generator and discriminator. You can use this, you can use for image to image translation and a lot of area, text to image synthesis. That is for example, this is the input. This is the ground truth, output like this. Similar to that image, it will generate some, that is the image transformation. So you can also do your work GAN for lot of research work. I think this is enough. I can conclude end of the sessions. Okay, thank you. Thank you for your cooperations.
Thank you, madam. Thank you very much. Myself, Dr. Rameshwaraya, one of the coordinator for this program, HOD CSC, madam.
Good,
Thank
sir.
you. Thank you very much for your kind acceptance and lecture about deep learning on computer vision. Thank you very much, madam. Thanks a lot. And I request my colleague Radhika, madam, to propose word of thanks.
Good morning, one and all. It's my great privilege to propose hearty vote of thanks on day 6, session 1 for 1 week ISTE-STTP on machine learning applications, research challenges 2020. I would extend a special vote of thanks to Dr. Jayapriya ma'am for sharing us valuable information on deep learning in computer vision and the real-time example, that is, we all know the COVID situation, COVID example for thermal detection and deep learning history, as well as the basics of that, and neural network with convolutional layers. Ma'am has explained us there are different layers where each layer is having its own application. I think each and every participant have known which layer is used for the purpose of different applications. Yes, and along with that, ma'am has explained a very deep information regarding deep learning frameworks and the importance of TensorFlow and Keras, which is very, very important for each and every participant, which is used in Python, and every participant can use it in their research work. Thanks a lot, ma'am, for sharing us different knowledge in this deep learning areas.
Thank you, ma'am. Thank you. Thank you so much. Thank you.
I would like to hand it back to our HOD, sir.
Thank you, madam.
Thank you, sir.
Thank you. We'll see you in future events,
sure,
madam.
Sure, sir.
Your cooperation is required. Thank you very much. Thanks a lot.
Thank you, sir.
Thank you, madam. Thank you very much from my side. In fact, there were no questions in the chat box.
Okay.
In
okay.
fact, other sir is also already is in live. Professor
Oh.
Radha Krishna sir is from NITWarangal, Professor and HOD.
Okay, okay.
Yeah, thank you very much for your
Thank
kind,
you, sir. Thank you so much.
Thank you.
Okay. Thanks.
Thank you. Sir, good afternoon, sir. Radha Krishna sir.
Yeah, good afternoon.
Sir, namaste, sir.
Namaste.
Sir, one minute lo start chedam, sir.
No problem, no issues. We can start.
Respected today's resource person for our present session of our program, Dr. P. Radha Krishna Garu, who is Professor and Head, Department of Computer Science and Engineering, NIT Warangal. Our Director, Dr. C.V. Krishna Reddy Garu. Our Coordinator, Dr. K. Rameshwari Garu. Faculty and faculty who are present here, heads of various departments, Dean School of Pharmacy and Management Sciences. Very importantly, my dear participants, very good morning to all of you and warm welcome to our present session. It's my privilege to introduce about present speaker, Dr. P. Radha Krishna, presently working as Professor and Head, Department of Computer Science and Engineering at NITWarangal. He has been in the profession of research, development, and technology adoption for about 28 years. His research interests include data mining, big data, machine learning, and databases and workflow systems. Prior to joining NIT, Dr. Krishna served as Principal Research Scientist at Infosys Labs, Infosys Limited, Hyderabad, where Sir was associated with research projects leading to futuristic intelligence systems and analytical solutions. Sir has conceptualized numerous research projects in the areas of CRM, social network mining, web sequence, test and image mining, e-check clearing and settlement, and financial inclusion, and associated in building innovation labs for leading industries. Dr. Krishna also served as faculty at the Institute for Development and Research in Banking Technology, which is popularly known as IDRBT, which is arm of the Reserve Bank of India and Associate Institute of University of Hyderabad. As a scientist at National Informatics Center, Government of India, Bhopal, and as adjunct faculty at NITWarangal and IIT Hyderabad. At IDRBT, Sir was an advisor to many public and private sector banks in India for implementation of end-to-end enterprise-wide data warehouse and business intelligence solutions. Dr. Krishna was also a member of IT Advisory Committee, Insurance Regulatory and Development Authority, which is popularly known as IRDA, India. He has been a member of research advisory committees of several academic institutions, also has been a member of an editorial or review board of international journals and reviewer of several international journals, including IEEE Transactions on Knowledge and Data Engineering, IEEE Transactions and Services Computing, Information Sciences, Data and Knowledge Engineering, Information System Frontiers, and Software Computing. Dr. Krishna has double PhDs, first one from Osmania University and second one from IIT Hyderabad. Sir has 15 patents granted in his credit, authored or co-authored 6 books, and has over 100 publications in very reputed high impact factor journals. With this little introduction, I really thank once again Radhakrishna sir for his sparing his valuable time and to be with us today. Thank you very much, sir. Over to you, sir. Thank you, sir. Welcome, sir.
Thanks for the long introduction, and thanks to you for following up for a long time, and with all the speakers and with me also, and thanks to the organizing committee who are invited me for this event. Good morning to all of you, and it's my privilege that one to be part of associated with this one. And as you all of us know, that is this is last session, and then many of the topics were already covered by the speakers. I will see that where is my share in the overall this entire program. So can I share my screen? So
yes, sir, please.
Yeah, okay. Yeah. So I'll try to minimize this one video. Yeah, just going through all these sessions, I observed it that there's a lot of things were already covered. So let me see the kind of what was left over and what I can cover and make you to be not monotonic kind of environment. See that how interactive that we are having in this one. So that's why I also chosen the topic as a machine learning trends and applications. So my idea is that when we should be able to look at the machine learning in action than just going for a basic theoretical things. Some of the things which I explored at my previous organization, Infosys Research Labs, some of the case studies were there, and which I will try to discuss as much possible in this 1.5 hour session. So actually, I'm looking at a different perspective of all these things. So the end of the idea of any AI or ML or even big data or maybe the deep learning. So thing is, we given a kind of a problem, that means we need to provide a solution for the given problem. So that means our main motive is to solve the problems, right? And then when the choosing of the problem is more important than the other aspects of it. So while understanding this problem, if we are very clear about understanding the problem, then half of our solution we might be got it. So that's why we have to be more provides a lot of time we need to spend on understanding the problem, because sometimes the problem appears to be very simple, and maybe you can have a solution. You have to go for a complex solution. So other side, you can say a problem appears to be more complex, but the solution could be a more simple. So we need to understand these things in better way before entering into the solving the problems. And one of the example you can look at it in the problem. So there is a star rocket launching, which was given to the one of the US university to solve that problem. So star rocket means the same vehicle will launch multiple rockets at the same time in the space, right? It will release. So they want to find out the trajectory of each rocket. So how to find this trajectory? So initially these people have tried with many sophisticated algorithm, because it's like a very complex, right? It's any problem in this one may lead to the problem, may lead to the collapsing the entire system. So it should be more appropriate to look at the things. It is more appropriate to look at things to see that how best that we can able to go. So though they applied so many sophisticated algorithms, finally they land up a simple linear regression model itself is very good. So because the trajectory that they want to find out, even if you have so many close points, even a linear fit maybe holds good better than any other thing, and also the computationally it is very light, because you don't get a lot of time to find the trajectory. Once it launches, in a few seconds you have to get the result also, right? So that's the way the people can, suppose initially itself they could have been tried this linear regression, they could have been got the better model initially itself. The other side of the coin is, suppose sometimes the problem appears very simple. Even in Infosys, we have got a project called, if you have an invoice document where all the elements like a invoice number, invoice date, all the things will be there, like things, and there will be like items will be, which are the items to be placed, right? The item number, item ID, item description, and then the total amount, the amount of that one will be there. And finally, you can have the total, and then a lot of other fields will be there. So in an organization, if you look at it, there's a lot of documents will be on this form, and they want to extract the data and store into a system, so that for downstream applications they can able to work on that. So the idea is, can they get this data? The document could be in the maybe it can be in the scanned form, or it could be in the kind of NITWarangal PDF document kind of thing, right? So extract these fields. So the idea is, suppose if it is like a scanned, or maybe if it is scanned, one can use any OCR tool, even the Tesseract kind of a tools can be used. The other side is, if suppose the native PDF document, we have the PDF box and PDF query. There's so many other tools are open source tools are available to find out. But even after having these things, then the next thing is only just to identify like a text processing, as in many of the places you have seen. So identify the text processing things, identify the keyword and then value, and then doing it. And note that it is even we have taken like 2.5 years, we have not completely had a solution to automatically extract the data and push into this one, because there are the vendors, each vendor is having their own layout, right, and their own representations, their own terminology. And sometimes when they're typing, even when the table data extraction is in today, it is a challenging task how to extract a table from a given document. Even you can use a tabular, because I have seen in the previous session people are talking about the Python. So you have a good number of libraries for there in the Python also to have this table extraction. But still you cannot find, suppose one particular item is having value here and another particular value here. Then suppose somebody wants an aggregation of this total amount of these things, it's very hard to get it. So So the problem appears to be simple, that means to only to extract the data and then push into the database, but you can see the problem, the solution could be more complex. So that's why we always look into that one, the various kind of possibilities in addressing a given problem. And maybe you may be seen for last 5 or 6 days how this machine intelligence can be advancing the technology. So actually the people who have started with the computers itself is started with the automation, right? But we want to automate the business processes. That is where the computation was started. But now we are looking for AI. This decision making system should be taken by the AI, right? So that means all should be like a AI driven systems. What does it mean? Suppose a business process is going on, maybe with various tasks or handling, that we are automating it. And some place, suppose if you want to take a decision, so instead of taking a manual decision, we want to take that AI to play a role in handling the decisions, right? So that means these are two extremes. One is like a simple automation of the task handling it. Other side is the decision-making capability to making it. So for that, we are having so many techniques which you already experienced things, right? So these things are more important when you look at this artificial intelligence, AI to ML to data mining to almost the current deep learning and data science. These technologies were there. But my observation is, it's not the point where you are maybe is required. These tools and technologies are required. But the important thing is we are living in this data-driven world, right? Where even in the big data scenario, so the data-driven world, and the more important is the data sense. So can we sense the data or not? So after applying these almost any technique, whatever you or we are comfortable that we can use it, or you can use a simple Excel sheet also. Somebody who is more comfortable. But at the end, can we make a sense out of the data given to us? So if we have done that, means our problem we are solving it. That means whatever that we are having as a human beings, what are these things that we have a cognitive knowledge that we are having, we want to incorporate that cognitive knowledge into the systems. So that's why we always will go for a human versus machine, where we try to incorporate as much as cognitive reasoning into the systems. So that's where our efforts has to be more placed into these aspects to look at it, how we can sense the data and get it. That means it's not the things that what are the insights that you are getting it. Today, there are so many problems which are unsolved. Though they may appear more simple, but it will be more unsolved. Even I'll show some of the examples for those things. Still, there are a good number of research is required to handle, to solve such kind of problems. Okay. So from those things, we have to see whether we are getting the actionable insights. That means can we add these insights? These insights will they add to my business or not? So if you are not provided any business value out of all our exercises, then there's no point of we say that we have succeeded in the system development of using this AI-driven technologies. Right? So that's why one of the thing is that any value addition was there for my business or not? If that is not the case, whatever that we are doing, all the things will be going a waste kind of things. So that's why we need to more focus on, can we add business value to the for going through this exercise of AI-driven systems? And this is the cartoon. Just I like always I like this. I took this from kdnuggets.com, and because we have seen that maybe in the previous sessions also you have seen a lot of deep learning technologies, right? So if you look at this one, suppose a couple went to the restaurant, and then they say that the waiter says, "You just smile." Right? The AI-driven system will take a picture of your face and will know exactly what you would like for dinner tonight. So that means they can know what your taste and what your interest and what you can order. They might be having the knowledge of what your previous instances, what kind of a item that you ordered and everything, right? So you don't require to order also. This may itself will, the waiter can say that the system, which is part of the smartphone, or the handheld device, so itself will take the picture and then say that it can know what kind of a menu that you are looking for. Okay, so you don't require to make it. But thing is here is, so we know that when the deep learning is good, and then it will try to analyze the lot of knowledge, and they also know what the other couples are coming and taking the items, and what is your interest, your taste in the previous few times. So they have a huge knowledge base and trying to get this information and try to look at it, what could be the choice of your one is there. Okay. But the thing is, even after having all the things, there's a possibility that if any, because any system will not give 100% guarantee. So there may be a choice of, sometimes you may land up with having some other dinner that which you may not like it. So that means whether even you like it or don't like it, you have to go for the AI driven systems today, right? And then you have to live with that. There's no option that will be leaving to us. Even today, if you are driving car, you put in the Google Maps, and you have to go what the Google Maps suggested the route, because it is very difficult for you to choose another route and then go to that one, right? So once if you depend on the Google Map, so you have to follow the Google Map, whatever that was, the direction was given by that map, right? So we don't have any option left to us, much option to left to us. So now the thing is, whether when we're making analytics, we also see some of the things that what we need to do. And some of you maybe already seen that when the few decades back, the people are interested in the data analyst position, right? And then after that, now there's the sophisticated way of coining the term from data analyst to data scientist job, right? So now we say that this is a data scientist who is very good in handling the looking at the data, and particularly with respect to this big data scenarios where we have this previous kind of a concepts and making it, right? So now there's a good amount of work is also happening in IIIT Hyderabad. They are also looking now, the new jobs could be like a datologist, because you have plenty of the data, that there's so much data was available, but all this available data, is it possible to see and then you can be better understand that one visually, right? So as a radiologist who can look at these diagnosis reports, right, and then give the what kind of the problem that you are having, the diagnosing problems. But similarly, the datologist can look at the whole large data, and then there's a possibility that one there is a very good analysis can be done. So that's why there's a change is happening in the way that we think also, right? So from the role of data analyst, what we used to do, and maybe it may be improved in the data scientist, then we may go for tomorrow like a datologist kind of a jobs also. So in of course, my core research area is the data mining. I just thought of the kind of a trends are happening in the data mining for the last few decades. I just try to list it out. There are so many areas which are coming up in the data mining area, where they want to see the kind of a patterns they are coming out, and the kind of a new data that is coming up, right? Because in the big data scenario, the data is not only limited to the structured data, and it is going to the more unstructured kind of thing, like a text, image, video, right? And then people are moving more than that also in today's data mining things. And you can have a good number of trends are happening. And of course, I may not be able to get some good words for these four. And some of you can give, I can also add to that, like a JK and Y and Z. But these are the things are happening in many areas, right? So that's why the research is going in multiple disciplines. So wherever that you suppose you have a good word which can be prefixed with mining, you can start your own mining research. So today, the machine learning, what we need is, as I mentioned earlier, the thing is the business processes are there, because business processes are the life for businesses, because they want to do their own tasks, right? So is it possible this machine learning solutions can be embedded as part of the business process itself? So today, no business is trying to wait that, okay, earlier our analysis is you give the historical data and then use some models and get the patterns out of the patterns. And these patterns are supplied to the business, and they'll try to see what kind of a strategies can be taken. But today, they are not having this much of the offline process. They're saying that, okay, at this point of time, what your model can suggest, right? Suppose if you are taking a picture, immediately you want to know your face should be recognized there itself. And we are not saying that, okay, it could be like a offline and can be done, right? So you have to, is it possible to embed this business process within this workflow itself? So that is the kind of a people are looking for today's world. Then people are also thinking about not for the reactive systems, they are going for proactive systems. So can you say that my car will go into the breakdown in the next 3 days or 4 days? Can you have early warnings for me? Can you give it? Or can you say my diagnosis situation is like this? Can you say that when there could be a dangerous will be there in the next 1 month to 2 months time, right? So that means, can we get some kind of a early warnings itself from the given data? And that's why even people are moving. If, some of you may be working in the maybe in the automobile industry or such kind of industries, they're looking for previously there's a preventive maintenance is one of the area, but now people are looking about the predictive maintenance, right? The lifetime they want to know, the lifetime was given by the manufacturer where you can know how to do the preventive maintenance, but from the operational point of view, they are not known because all the people may not have the similar kind of thing, right? Even suppose if I am driving a car, is entirely different from how my son drives the car, right? So now this predictive maintenance will try to say that, okay, when you can go for a next kind of a maintenance to be done, which are the components to be done. So people are looking for from reactive to a proactive. And then people always talks about the real-time kind of analysis, right? But there's a good term is that instead of real time, we should have a right time, because when the decision was taken, when the information is provided to you, or maybe when you're retrieving the information that the system is giving you a good information, it should be at the right time, right? So it's slightly different from real time, because maybe right time may include real time, but right time is more appropriate for the usage of that particular patterns or particular insights given to you. Suppose if you are going in a flight from Hyderabad to London, and in between, suppose in a Dubai airport, the flight was landed, and you got a message saying that the kind of a book that you are looking for in a particular shop is available in the Dubai bookshop, Dubai flight before in the launch. Suppose you have a lot of book stalls, right? So if it is available there, so in the airport, if you have that shop, if you get the message, suppose if you got that message when you are not yet landed, you do not know whether you can have a sufficient time to reach to the shop or not, was not known, right? And then even if you say, if you landed, then you got the information, but you don't have sufficient time, then also there is not much use of it, right? But suppose if once you got the message, if you're taking flight again from this Dubai to the N, then also there is not use of it. So you should be able to know the kind of a book that you searched in the bookshops, in the online bookshops or maybe bookshop in the Hyderabad, right? And availability of the books, that book in this one, and see that how much time is there from going from one terminal to another terminal, right? And whether in this particular time, whether the person you can go have a sufficient time to go to visit this shop or not, kind of, right? So this should be like if you get the information at the right time, then there is a benefit will be there for the end user. So that's why a lot of challenges from the business point of view, people are looking at, can we get a right time kind of answers, a right time right time availability of the knowledge. Then of course people are looking the distributed parallel computing. That's what people are very tried with the earlier our programming paradigms, right? Using the CUDA or maybe GPU or maybe any other distributed computing facilities. Now people are moving towards the edge computing. That means though you have a computational facility of a high-end computational facility, is there any possibility to make some of the computational facility at the edge level itself, or maybe at the device level itself? Suppose in the camera you have seen earlier. So this camera itself is good enough to decide. So what kind of a menu that you are looking for, rather than sending this camera, sending the information, everything to the central place and then compute the things and then going it. So by the time the people who are hungry can say that no, now we don't require to take food. Right? So it should happen at that time itself. So that's why we need to also see it's not only the kind of algorithms that we are using it, the kind of a application, how it can be done in the real world scenarios. Right? So that is a more important aspect. Please stop me whenever you have a question, because it's difficult that maybe I may be knowing that the people who are having questions looking at the chat box. So look at the trends. I'm sure that you maybe covered some of the things, but I'm looking at the from the data. I'm trying to make these trends from the data perspective and then technology, other technologies perspective. So one of the trend is going on the social network. Today we have the data that in the social media. People are using the WhatsApp, and daily you have a large number of video files, and maybe the text message you will share WhatsApp and then Twitter, Facebook, right? The many places we have the large number of data is coming, and the kind of data that you are working on, this is entirely different on the normal data, the business data, right? Business data is having very more structured data, right? Or even if it is unstructured data, there may be a good number. This is like a good policies and everything will be there, right? This is an unstructured data. But when you go for this social data, where people will write their own comments, they take their own videos, not having any kind of even it is very difficult to find the structure itself, right? And even if you are if you are forwarding the message to your friends, and the network that you build, so the friends network, right? You are having this friends network, and it is very difficult to analyze this kind of data. One side is you are having a very huge data, large data is coming up, and second is you have a relationships across these things, and third is the content that you are sharing, right, is not even the, it's like a, in the case of a regular data, unstructured data, you have a good English and everything, right? So you know this, how the sentence formation, can I handle the can I face finding a sentiment of this one, right? But where here you can see everybody will write in their own format of it, right? And may not follow any kind of a structural form of it. Like structure means there should be like a long specific parts of speech they will use, kind of thing. They may not use, right? So still you have to go and then try to analyze these things. So if suppose the data is with respect to social data, and the kind of algorithm that you use here may not be straight away fit into the social data. So you may have to be fine-tune those models to suit this social network data. So then now this people are coming with the IoT kind of environment. People are looking, the data is coming continuously, streams, right? So that's why I look at data stream. And there's a good number area was the data stream mining. People have started. Even the storing the data streams in the database, you should have a different kind of databases. Maybe you may have seen in some of these things, like in the Spark environment, people are having, you can store the streams data, right? So the important aspect from the machine learning point of view is, earlier you take the data and then huge data you take and develop, get it from the knowledge of the data, we build a model, and we use that knowledge or patterns to do that one, right? So if suppose if my model is not this is not a good model, then I go for another model, or I may go another model, right? I will try to so many models, and then finally I will come to this one. Now we can see the stream is coming. Now the earlier understanding is, if you have a data and any new unknown sample was given to us, we can easily use this any one of the model which we feel comfortable and predict it. But now you can see the data is stream, and we don't know when it will come. And one thing is, it's very difficult to find the offline models, right? And then even if you find a model, by the time you click for this data, right, you want to analyze, by the time this data may go, and you may get a new data, new window of the, suppose if you say okay, Windows, so you can get a new kind of a data, right? That means maybe we need to change our thought processing itself. You can build so many models which you do not know which is good for that kind of a scenario, and then see as the stream is going, is it possible that model can look at the stream, correct? Model can look at the stream and say, am I okay or not with this which kind of a data, correct? So then what will happen? This the model will be chosen. The data itself will choose the model which is more perfect enough, and then take a decision on top of it. I'm not sure whether I was made clarity on this or not, but that's what my idea is. So as stream is moving, like you can see in our map reduce kind of environment, the data is moving. Actually, data is sent to the processor, right? Earlier, computation is moving to the ones, but now the data is moving to there. Similarly, we can say this model the data has to decide, because earlier our model is to decide the fate of this data, right? Now this model the data has to see whether I am more applicable to which kind of a model, and then I have to go and evaluate it. So of course you require you need to develop a lot of mechanisms to do that. So that's why people still is a good area is how to make AI technologies for the IoT data, the prediction models from the IoT data. Right? So that's from the stream data things. Of course, you may be seen the lot of previous talks, unstructured data, right? The text, image, and video, speech, and all the things, how it can be done. I'm not spend time on this. Then the sequence data. This is also important. That's modeling the sequences. So, of course, stream is okay. That is the rate at which the data is coming up, and the sequence is how you are having this data within the data itself. The sequence is going. And if particularly look at it, the sequence is, if you look at like a text kind of a data, you may be seeing that the LSTM kind of approaches you are using. So sometime of the sequence modeling also can be, some sequence part of it also it will handle, right? Whether you need to bind to the before or maybe after these words, right? So this can good LSTM models will happen. But sequence is not only this one. Suppose maybe the data is coming more often, right? This is a we need to see, one is like we need to go for one axis, one dimension, then another dimension also important, right? So is it possible to find the sequences? Now most of the models will handle the sequences among these things, but is it possible to have among these things also? One of the work we are doing currently on the conversational data, where one thing is you have to analyze each and every conversation. Correct? When a conversation means it is having a set of words, correct? It's the sequence of words, not a sequence of words. Right? And then once you suppose you ask a question to a chat box, maybe you get a response, another response you got it, and then you may ask again a question, and then you may get a response. So like this, it will go. The conversations will go. Right? It could be a chat box, or it could be like a call center kind of thing. Right? So now see now it's not that only you look at the sequence availability of the sequence within this one to take a what kind of a intent that you are having while conversation. But you can see the intent may change over a period of time when you are going it, correct? So even the sequence data, the previous sequence data which we cover in the associational mining, like some of the extendings of a priori models in the sequence association rules mining, but in the sequence classification approaches, sequence clustering approaches, correct? We are having these kind of things. But now you need to have a different kind of environment to have this kind of a analysis. Then of course unbalanced data, this where the data set itself is not balanced, because most of the algorithms will understand the data is in the balanced form. But what happens, some of the applications, the data is more unbalanced. Like if you have a training at 90% of the data and then testing at 10%, right? Or maybe not this training and testing, but the kind of a class label of one class label you are having the 90%, and maybe another class data may be having only 10%, right? So the algorithms may be biased towards to the class label which is having more number of samples than less number of samples, because it's very difficult to find this one. A good amount of research is happened and going on, also still going on in unbalanced data. And actually there's a good amount of research is currently we are also working on how to have, when the data streams are unbalanced data streams were there, how online learning can happen when we have a online unbalanced data streams. Of course, privacy and security is evergreen area. People, whatever that work we are to do, it will still will have the privacy and security concepts to do that. And of course, the kind of a maturity as it progresses, and you have a both issues, security attacks, and then privacy things will always happen. So one has to think about the privacy and security, which is it should be continuously has to be updated. And this is where actually I was actually more interested in things where most of the time we will say that we have a large amount of data, and even we say the big data scenario, correct? We talk about the zettabytes of the data, correct? But what will happen where even though we have a large data, and at the end of modeling, when it comes to this modeling part of it, you may be seeing that one the availability of the data is very less. So is it possible to say some of the is it possible to modeling develop systems when the data is not much available with us, right? Maybe a simple scenario is somebody will ask you to do the tsunami prediction, right? Suppose you say, no, yes, I am a very good, I am very more comfortable in the machine learning and data mining areas. So give me the data, I will do it. Then you say, okay, then let me, so what data you want? Suppose you say, at least give me 100 samples of the data. Correct? Because unless we have a large data, because we usually talk about 1 million records, kind of things. But because here, at least you say that, okay, minimum at least 100 tsunamis data. Because by the time of you get 100 tsunamis data, maybe 3-4 generations of generations may go, correct? So because the availability of the data is not possible, maybe you can say maybe 3 or 4 maybe possible to get the data, but you may not have the 100 records of that kind of a thing, right? So in many cases, if you really comes to the place that you want to work, which I have shown earlier, that invoices, we have a huge data was there, but you do not know a particular sample, unseen simple. This is, see, our model is always will depend on the unseen data, right? This is the unseen data which we are giving to after modeling it, unseen data we want to predict it, right? See, our idea is basically the training data is most representative for this universal representative, right? But as you go on see the unseen samples which are different from this your existing things, it will differ. Your decisions will also may not be good, right? So then we need to have a good kind of a knowledge models for developing this to deal with the unavailability of the data. From the other side is like a technology perspective. The trends ML is going from the technology perspective also. Okay, they're like you may be seeing the IoT, connected components, image, big data analytics, data fusion, and the social signal processing. I will give some of the case studies within the social signal processing also. Now, thing is, the people are mostly working on this these things, data fusion, and then these kind of things. So this is a you may be seen there's one of the area popularly coming out today is multimodality AI. I don't know how many of you heard this one, multimodality AI. So that means AI is not only simply we go for either a structured data, or you can say I'm having a speech data, I have a image data, right? I'm having a text data, the structured text, image, video, right? You have some facial expressions, body language, gestures. There's so many are there, multimodality. So can you handle all these things? Right? Suppose if you want to today analyze the prediction, you can want to predictions for the US elections, so you can see how the things are happening, right? So it may be having so many things. Suppose unimodal, yes, we are very strong. Suppose if somebody giving me a text data, I can say I can analyze the text and then give things out there. If you give me a video, yes, I can give image, okay. So you can give any unimodality is okay. But thing is, if you go for a multimodality, can you really get the what you are expecting it? Yes, you may be having lot of data was there in a different modality data, but can you easily get these things? But is it that can you fuse the data, right? So now now the trend is going on for each and every aspects. We are embeddings are coming, right? You can say a text to vector, a word to vector, text to vector, image to vector, right? You are representing the data itself is changing. So when you're changing this vector representation, suppose you are having this text data, and then suppose you are having image data you are represented, right? Now, is there any possibility that you can have a different representation of a vector, the combined vector here, right? Whether this vector will be having a addition or multiplication of these things, even if you say, okay, so you followed any one particular thing, that addition of these two things, can you say that when these two are linked? Because here the speech which was there and the kind of image that you are showing, that facial expression you are showing, maybe tallying or not, right? Even if we have a good number of representations, it's not an easy task to say how I can have a combined feature. Suppose assume that one, okay, I don't require to have a combined, so I have my own representation classifying doing it, but I have doing a classification here, then at least can you have a high level kind of a thing, right? So you there are a lot of work is going on, the research is going on, all the things. Is it possible to core learning? Right? People are having this one now today. People are looking for, is it possible to can have a core learning kind of things? So this algorithm perspective, this is what most of you may be covered, because I'm not going like a supervised, unsupervised kind of things. People are already done. this modern the learning paradigm from the algorithm perspective, because I'm looking at from the data perspective and then technology perspective, and then going for the algorithm perspective, right? So from the distributed parallel processing, we have a good amount of work was already done, right? This representation learning, as I mentioned, the kind of representations which are happening, this okay, how to do this one. But today, even in the deep learning, is also a kind of a representation learning where you don't require to identify which features that you want to make it, right? This because the technology making our life simple. Earlier, for a given data, if I want to apply a particular model, I have to first of all extract, identify the features, and see that which are the features having more impactful and more having correlated. And then after identifying all the things only, I can able to make it my learning process, modeling process. But now in the deep learning, I only just give my input, and that itself will take the CNN or maybe the latest models of even auto encoders and decoders, right? So even transformers which are recently coming up. So all the things we only give the data, get an input, and then we can get this knowledge out of that. We do not know what is happening in this one. And sometimes we do not know. We are mostly depending on these modeling capabilities, right? Which are having a black box. So I cannot know what is happening, because but I have to believe it. There's no option for me, because this was trained when huge data. There people are training it, and all these are black boxes for me. And if you ask something that okay, why I have to, how I got this kind of insight, there's no explanation. The models are not interpretable. Correct? But even if a model are interpretable, assuming these are black boxes, we are still depending on that and giving it the information. So of course, this is transfer learning. Again, it's a part of a we are making it multiple things, even in the deep learning kind of a things, right? So what happens? These models, the models will automatically, like you can see in the bright models and everything, when you're learning it. Yeah, they already learned on some of the data sets which are available, and the same knowledge can be used if you are giving a new data set to that one, right? So that means experience in one domain will be useful to the, you're using same domain, same experience into the another domain which was not known earlier, right? And then a lot of work is happening in the kernel based learnings. So even they want to develop new kernels, right? Even if you look at the earlier days, we used to say in SVM we have a kernels and trying to understand what are the good kernels that we can use, right? Whether we can use some of the functions like a RBF or maybe ReLU functions or maybe anything. There's different things we want to use it, right? And then people are now trying to make the kernels as specific to the application or the domains specific things, and build a new mathematical models, right? So to coming with to solving the problems. So another is like active learning, where people are started of looking at the instead of looking at passive learning, like people are moving to active learning, where the learning has to happen on the fly, right? So any questions? So there's active learning. So these are the algorithm perspective. We have a good number of progressions happening in various techniques. And today, even as a machine learning person, our job making more easier. We need to identify which model we want to plug it and then do it. If not, we have to change only one line of the code, and we can try with the other models and then doing it. Right? So the efforts of the life cycle of your machine learning earlier was completely gone down. So earlier, say you have to understand the businesses and then look at the data pre-processing, then look at the your model capability, and then get the patterns, and whether the patterns are useful to your business or not. If it's not business, then you can try again to look this one, right? The kind of a crisp data mining methodology. But now those days have gone, and say, oh, give me data set. Okay, this is the data set you are having. Okay, come to the Python. You come to these are the Python libraries already available. Fix in this one and get this one. Now you use it. Right. So the life of the data scientist will become more easier. Maybe one of our best thing is if you want to don't know this library is not working good, so go to another library. Or if suppose this particular model algorithm is not good, then only you have to change this model, because there's certain things you don't require to change because somebody else already coded for us. These are the use cases. I will skip it. This one. Yeah. Let us spend some time on the case studies. So one of the one which I did is like predictive modeling, which leads to the impact analysis. So the business scenario is like this. So each company is having a huge financial databases, right? And they want to use the database to prepare a kind of a research reports. And usually they give it to third party and like a critical kind of a things, those who rated this company, and they give some kind of a rating, right? So now this, suppose this agency like a rating, the critical kind of agencies are KPMG, there's so many agencies are there, right? So if these agencies, if for a particular one company one, but suppose particular company one, if they don't, if suppose they give some kind of a rating, based on this rating, you can see the stocks will be there's a lot of impact on the stocks, correct? Based on this kind of rating. Suppose if this the agency is not properly rated this company, then the shares will go down and it will have a huge impact on the businesses, right? That's what we usually monitor. So that's why research analyst needs a decision aids in creating the research reports, which are required for the investor community, because the investor community will look into this one. So they have, that means they have to take utmost care for a particular company to give the ranking, right? So the problem was given to us is can we develop a diagnostic tool, right? So which can perform the both present and future scenario analysis. That means they want to do this publish research reports and see that what are the analysis is coming, because you need to predict it also, right? Because you have the lot of parameters. Based on the changes in the parameters, you have to find out what is how the company will grow, how the business will be there in the future. Based on this only, the people will go to try to invest it, right? So is it possible to generate a published reports, generate alerts, and also is it possible to forecast some of the values of interest? So we have gone to the Bayesian network. Actually, Bayesian network is an extension to the like an naive-based classifier, right? In the naive-based classifier, the thing is all the attributes are independent, right? With the basic assumption which are having, but whereas in the Bayesian belief networks, we see some of the attributes are maybe having a relationship, right? They have a relationship. That's what we assume in the Bayesian belief network. So we have considered a Bayesian network. And a Bayesian network, I'm not going to the technology side because people have covered. So I'm just looking at what are the essential required for the understanding the case study. So each and every node having a CPT table, the conditional probability tables, and these tables will be helpful for us in analyzing in doing the predictions. Right? So these are for each one we are having we have a conditional probability tables. So how the tables will come? These tables will be arrayed based on our data supplied to this one, right? So this kind of a case study we are having. So they given for some kind of a airline industry, that industry was given to us, and we divided the data into 3 parts mainly. One is like a macroeconomic parameters. So this macroeconomic parameters is very good for the more country specific parameters, right? Like a GDP, oil price, because they all affect the company performance, right? So then there's another set of data which I was just masked it. So there is a industry specific variables. That means suppose if we are working in the airline industry, so for the airline industry, what are the parameters for the airline things specific was there, right? There are routes or maybe the kind of a number of passengers and all this information. And one is the last one is the company specific information. That means a particular company, of course, we did for the this US airlines, but like in India, you have like Air India, Indigo, like that, right? So each one company is having their own data. So like their own revenues and everything, right? So there's so many parameters for there making it. So the idea is here. Suppose is it possible to find the influence of suppose there's an increase in the oil price, whether it will affect my sales revenue or maybe the net income, what is the impact of that, right? Suppose the company looks for, can I increase the revenue for 20% by next quarter? So what strategies has to take to be followed in the for next quarter, right? So that means I want to see, I want to have a kind of a business strategy, right, that I want to see that this 20% increase. So then which are the parameters that are affecting? So then if suppose there changes were happening, then how I can able to take a good strategies out of it, right? So this kind of a Bayesian networks are useful for many applications, though it's like a very old one, but still very useful and can solve a number of applications. So the application could be like a sense and response kind of a thing, sense and respond, right? So that means you say there's an increase in the GDP, then what is the impact is happening? How to respond to that, right? Suppose you can say root cause analysis. Now you can say suddenly my income was dropped. So what is the actually effect of this one? So can I find the root cause for that? Okay. So I can do behavior analysis. I can see a lot of analysis can be done. And look at it here. The beauty of the this Bayesian network is usually if you train a model with a, suppose with a k number of features, right? You have a k number of features. If you train a model, and if at all you want to predict an unseen data, you should have always a k number of features, right? If you don't have k number of features, it's not possible to many of the models cannot be used. But here you can see, even suppose somebody was not given one particular attribute value, but still if they have with the other 3 attributes itself, you can use the data, because for the particular node, because node means each node is an attribute, right? For a particular node, you have the already knowledge is available. Node specific knowledge is already available. So based on that, you can easily take and you can take the decision. Even if you want to say that okay, suppose you are having a one more attribute which is also playing role, you can just simply add that role here and then can translate it. And over a period of time, this is you can have it kind of a random CPT value for this, and then over a period of time it will be learned and then it can be used as part of this. Okay. So because today, if you look at the evolving systems, we cannot say that okay, this is the only data that I can get always, right? That is not in our hand. Okay. So once we have the model such kind of a data, then one can easily try to find this kind of a predictions in inferences. Like this is one of the things I'm just reading it out. When oil price is down compared to previous quarter, that is the evidence that we are having, right? Probability of sales revenue being up compared to previous quarter is 90% based on the past data, right? So say what we are doing here is we are going for a evidence-based reasoning, right? This is the evidence-based reasoning which is coming up. And if you look at the company quarterly reviews, they will always compare with this quarter review with the previous quarter, and also previous years the similar quarter, right? So they always will be comparison will be there. And of course, as a market, what an investor will see the company C1 and how company C2 is going on and how company C3 is going on, right? So that is the kind of a data people are working it out. Or of course, you can also see how the things are happening in a simple scatter plots also. So till now here, what else things is there? We have a given data, and we because we know the knowledge of some models are there, we are modeling it. But the actual problem starts in the real world scenario. So that's what I want to give more emphasis on that, because it's not a things are there. Of course, for publishing research paper, what we do, we try to download data sets from the Kaggle or UCA repositories, different data sets, and develop and implement on our algorithm and implement on all other algorithms also, and compare the results with maybe using a confusion matrix or precision recall, what is the values, or maybe ROC curves, some kind of a measurements we take, done index kind of things. And then we'll see our algorithm is always gives a performance better than, suppose earlier was giving like 83.6. So now we can say mine is giving 84.2 and we'll publish a paper. It's more easy for the research community to solve these kind of things. But thing is, in the real world, it's not like that. You say whether it is a 84.6 or 82.3, at the end, whether they're having a business is improving it or not. That is at the end of it. The business manager may not look at what model that you want to use, right? How making it. So the actually challenges will come if you really wants to implement these solutions in one. That's why when I moved from academics to the industry, I faced these are the things which I faced it. It's not only the algorithm. Algorithm is only a small portion of the overall scenario. So the thing is here, when we started this project, they mentioned it. They have a 10 years of the data, and I'm talking about maybe a slightly old, maybe around 2009, 2010 time. This is during that time, getting data is very hard, and we are very much happy to see that when the people are saying that they have 10 years of the data. So that means we have a large data and we can do really good analysis. Okay, but over the period of time, not period of time, over we are analyzing the data because they have a huge database and then given us this one. But what happens when you want to apply a model, you require the kind of attributes or features, correct? You have to identify the features. And as we've seen in the Bayes network, all the nodes are the features for us, right? So if we have these are the features. Once we define, these are the features which are required for doing an analysis. And from this data is like a scattered data. Data means it's like unrelated data. Right? There's a lot of data was there. When we want to frame this kind of a data, at the end, what we have observed is quarterly one record only we'll get. We get only a quarterly one record. Actually, at my place, I lost the power, and I think the system may go down anytime. Just please bear with me. Otherwise, I will move to the another place. Just give me some time, just 2 minutes time. Just give me 2 minutes time. So.
Okay, sir.
Sorry, I'm back. So sharing my screen again. So here, am I audible?
Yes, sir. Yes, sir.
Okay. Sorry for this, because as a technology also we have to see the power problems and everything in the home.
Yes, sir.
So the thing is, the 10 years of the data, which I say the quarterly one record, that means I have got only how many? The 10 years means there's only 40 records. So that's why I mentioned the unavailability of the data, correct? So it's very hard to see 40 records. And even if we come to like a monthly wise, we're getting the one record with a lot of missing values. Even it is month wise, it is only 120 records. So that means very small amount of the data was given. So of course, for us, because when we've seen the data and understanding the business perspective, the model, we already find this structure Bayesian network, correct? And then for us, we don't have any problem. So what we need to do, we have to give the data for this Bayesian network, model it, and then we have to go start from the inferences, diagnostics, and everything. Correct. The thing is, because this is like a commercial project, the client asked that one. So how you can say with the 120 records of the data, how I can believe the predictions? He's having a valid question because he knows if you want to develop any models, you require huge data, right? And then with the less number of samples, you are giving a model. That means you may be giving like a wrong information to us, wrong models to us, right? Because it's in a commercial environment, we cannot go back and say, okay, anyhow, this paper was not accepted. Let me submit this paper to a new journal. It may not be that case. So I need to look about the continuity of the project, right? So then what we did is we have done this sensitivity analysis. The basic idea here is what we did is, can we perturb the data, right? So each and every field we are having, can we perturb the data and then use generate the samples? And what we have done is mathematically we have taken this sensitivity analysis and changes these things and look at the generate huge number of data. And what we have guaranteed is, as long as this any field you take the data which will not move this range, given a valid range, so the inferences will not be differ. So that means, suppose if you can say oil price may not change drastically from in a day. Suppose in Indian scenario, it may not go to the 500 rupees, right? Maybe after 10 years may go, but now it may not go, right? Or it may not be less than maybe 30 or something. So in case suppose tomorrow a new sample which is coming within the range of this one, but still the inference is correct. The inference, we are not saying that inference is suppose usually in the discrete inferences here, like a high, low, or medium, assume that one, the three. We are not saying that it's like your revenue will be high. But based on this, it will itself having its own predictions and doing this one. So then we need because it's not like only perturbation, simply changing the value is not sufficient. We should give a mathematically prove that yes, this will be applicable and then giving the guarantee. So then next is like a scenario analysis. They say they give a lot of scenarios, and can you solve these scenarios from various data giving it? Then the missing value generation. Why I am more stressing on the things is here is, see, each one itself will come a good research work. Though we say our modeling is, we always have spent time on this modeling. Okay, that is also one way of doing it. But you can see here in the missing value generation itself, because one of the brute force technique is you can find the average of this data, right? In a particular column, if you are missing some values, what usually we do, we'll try to do this average of this one, or maybe maximum value, minimum value, or maybe sometimes we'll take the nearest neighbors, right? Except this one, all other attributes will take the value and try to find the k nearest neighbor records, and from those values, whatever is there, best one is there, we can assign that missing value. We have so many strategies to define the missing values, but in this case, in our case, because we model the data in the form of a Bayesian network, right? We know the relationships. Suppose a value is missing for one particular attribute, we know, or from the related attributes from this one, that the relationship exists with the other data, right? And then from this one, we know other data also. So we have gone to our dynamic programming approach to assess the value of a missing value for a particular attribute based on the connectedness of the other attributes, which may not be there in our regular estimating the missing values. So then the trend removal, this is also another interesting aspect. Usually what will happen, due to some circumstances, my sales will be fall down and they may be improving, right? So these things are not useful in doing the analysis. Maybe sometimes there will be certain sales may improve, and maybe certain sales will be got down, and maybe the parameters may go down because maybe due to pandemic situation, maybe 6 months there is no operation, business operation, right? So always we need to look at this, how to remove the trends. And trends means like here uneven scenarios can be removed. Then one more activity which we spend a good amount of time is on the discretization, because this Bayesian network, all the attributes, the input supposed to be in the discrete data, and also the predictions also in the discrete data, like high, low, medium, or kind of things, the discrete data. Now, when we have this discrete data, and usually you can see the parameters, all this oil price, everything are there numerical, right? They are numerical data, and this numerical data we need to convert into discrete data. Suppose if you take some kind of a ranges and discrete means like a bucketization also, or discretization. Here this if discretization changes, that means the value of a particular bucket changes, then your analysis also changes. So you need to find out the appropriate buckets for each one. But in this case, again, what we have gone through is, so there's a relationship among these things, correct? So that means the kind of a discretization happening here is also a depend on here also. It may be depend on the other parameters which it is linked. So traditionally, the discretization will happen for each and every attribute. Now we are taking again the same approach which we followed here, this dynamic programming approach. Same thing we followed to make the things to find out the which is a good discretization technique. So then, of course, probability computations, because this is CPT is maybe straightforward, but as I mentioned, because some kind of attributes which are coming up, how to add the new probabilities, right? Then actually our actual problem started in when you're deploying the real world applications. So these are all like technically we're able to solve them and then address all the things, making them to satisfactory. But at the end of the thing, what is because see, we need to satisfy the clients at the end. So they asked us, can you give a single value, forecasting single value? So what is the output of this Bayesian network? The discrete data. That means discrete levels, right? Discrete levels are there. Maybe you can say high, low, or medium. An example, this is right? High, medium, or low. So what is the inference we are having? Maybe this, if your oil price is now increased by 20%, maybe your sales revenue could be in the low. But what they are asking, I don't want to say low, but tell me what is that value. Tell me the exact value. So now comes here the actual problem starts. The data was given in the numerical data, because all the oil price, sales revenue, all things are mostly the numerical data, correct? And then because of the Bayesian network, the model that we have chosen, we have transformed this data into discrete data and then put up this one, and then given also the predictions also in the discrete form. Now the requirement is the continuous data, that is forecasting a single value, correct? Single value. So now if you want to get this single value, if I given this one, suppose if this requirement is there in the beginning itself, I don't require to do this one. I don't require discretization. I don't require this one. I don't require these things. I can straight away I can apply some good regression techniques, because it's a numerical data. I can able to predict this value. I don't require to do this much exercise, right? But initially, when we are saying this Bayesian network inferences everything, they are happy. But when they ask the additional requirement of the single one, the forecasting value, our model itself is entirely gone. No. The efforts that we developed in this one, because it's like an industry scale project, right? So, but at the same time, we cannot go back and say, okay, you cancel this and then we'll have some applied regression algorithm to do this one, because the project is already ongoing. There are a lot of revenues of our company revenues also will changes, correct? So then what we did is, because anyhow you required forecasting one, and whatever that the Bayesian network gives we are already using Bayesian network. Now we need to augment the Bayesian network results with the regression techniques. Can we augment? Because it's not like simply augmenting means not straight away giving these results, both the results, and doing it. It's not like that. So because we have to see the usability also, correct? Usability from these models. So then what we have done is, we have done some kind of again establish a mathematical relationship between the regression and then these things both, okay? And saying that the predictions which are happening here, see, if we don't have a Bayesian network, if I apply a traditional regression analysis, my prediction is based on the whole data set, okay? But if I have a Bayesian learning, I can identify for certain data records which are falling under high, correct? I'm only taking those aspects. I'm now going for those regression on those things. That means I'm just filtering it, correct? And filtering based on what? Filtering based on the Bayesian analysis. So then I'm making more predictions. Suppose if you look at that prediction as a whole, at a global level, it may come to like into a high. But actually, if you look at the local level, because you already decided on the base analysis you got only low. There's no point of considering the other records. You take only those records which are having a low and do the regression. Always this will be in this range of this low only. That could be the good prediction considering this one rather than going for a regression on a whole data set. So then we've gone for this forecasting a single value. Then what has happened is, of course, this particular project is over at this place, but the same model when we developed, we also going to the given for a Boeing. Boeing also wants to do some analysis for some project. Okay, so we use the same model, but they also like this one. Everything is over, but they are having a very good statistical team. They have a very good statistical team, and they want to say, okay, now you are giving this forecast single value. We like their approach very much. But they say they want to say instead of a single forecasting value, can you have a range prediction? Now we can see this suddenly the entire area was changed. Usually what will happen in a single prediction, we say y is equal to mx plus c. Suppose if you take a simple linear regression, right? Maybe I have to find out the coefficients of beta 0 plus beta 1x, and I think if there's only one attribute. Otherwise, if more is there, I have to say beta 1, beta 2, x2, and so on. Coefficients I'll try to find out. So the understanding is, suppose we want to regress the particular straight line, if it is a simple linear regression, straight line, and we'll take this error rate and then doing it. So what will happen here, any prediction of a particular point, we're making, this is the prediction, we are getting this y value, we are predicting the y value, the response value. But the idea is, it is taking care of this prediction. Usually we say y cap, right? This prediction having these error terms. Though we minimize the error terms, there will be always error will be there, right? So, is there any possibility rather than predicting a single value, can you give a range of values for my prediction, right? And even they're saying, not only this range, can you give me for future also? It's like a cone kind of a prediction, right? Cone kind of a prediction. That means the ranges also may go on increase also. So then we started working on the range prediction. So we developed a good models for the range prediction. And of course, still we are working it out because, of course, for at that point of time, we developed for the cone kind of prediction. But now there's a possibility in the real world scenario, it could be an arbitrary shape also. The data could be arbitrary shape also. Then how you can predict it? So that's what we're currently working on, some kind of an envelope theory and all the things we are using and then developing it. So another application which we did is this financial statement recognition. So recognizing a financial statement. So the thing is, you have each company is having a financial reports, and usually those financial reports are having pages like 100 pages, 500 pages. Some are having maybe 1,000 pages also, right? The financial reports. So out of this financial reports, the companies wants to analyze the financial statements. Financial statements, the balance sheet, expenses statement, right? So those kind of statements they are looking for it. And then there's a concept, there's a work is there, and the financial spreading. That means, so from this financial statement, from the given this entire document, the overall document, from these documents, you identify the pages which are specifically given, specifically having the values of these financial values. And from once this you identify the pages, you can use some techniques to load into this one. So here you have a lot of financial ratios. You have a lot of financial ratios. Of course, these financial ratios are more good formulas are there. Based on this data, you can get this one. So this part is more straightforward because the very specific rules are available. The challenge is it possible to develop a system from the large number of pages, huge number of documents to identify these statements? And you think of it, these reports, each company is having their own kind of a reports preparation. All companies don't follow a similar kind of thing. And also, if the region changes, the terminology also changes. Because here you say salaries, and some place they can say wages, right? Some expenses, some terminology, some term is there. It could be some other term in the other places, right? So And also not only that, a financial statement, like you can say balance sheet may not be there on a single page. It may span across 2 to 3 pages, right? So how you can determine a financial statement? That means how you can recognize a financial statement for a given a financial document. Okay, of course, this entire thing is as part of the financial spreading, but this portion is straightforward for our engineering team has done. But our role is actually mainly comes here. Can we develop a automated solution to say this one? Right? So now, see the challenges which are happening. One thing is the balance sheet can have go for more than 1 pages. Another thing is a company can have its own subsidiaries, and subsidiaries also have their own reports, which are all there in our big report. Right? If you're looking for a balance sheet, somehow if you can able to recognize, you do not know whether the balance sheet is for the company one or you are making this subsidiary one, right? So this is the actually an application where we have taken this our training data is actually looking for this annual reports and page numbers of financial statements, and we have tried to do this one from the key phrase extraction, right? Because we have this key phrase extraction. Then we have applied the associational mining. Of course, we have used the latest efficient mining, but you can say simply think about it like April also could be a good candidate. So we generate frequent item sets. Why we need a frequent item sets? Because the kind of the frequent items that was coming up for each and every kind of a domain, because healthcare companies can have a different kind of a report, financial companies will have a different report, and then automobile industry can have a different kind of reports. Asian region can have a different kind of reports, right? There's different aspects for there. It is very hard to have a identify first to classify that one and then going it. So what we have done is we have tried to generate the frequent item sets, and from each frequent sets, whenever there's some kind of a new financial document was given to us, then for each page we are trying to look at it, how much rank strength was there for each and every frequent item set, and then based on that we are trying to rank it. Okay, so we applied some kind of a neighborhood approaches and then translated into this one and identify which is the page could be like a balance sheet, which is like a profit loss statement, like that we are identifying the recognizing. But of course, I may explain very at a high level, but there are a lot of things has to be done to achieve this one. Okay. So another work is on the social signal processing, which I mentioned, projects like a conversational AI, right? The multimodality AI and conversational AI, which is one of the good area which was we are working on this one, this conversational AI, right? So here, this is a social signal processing where we are trying to find the emotion discovery. So this is actually we worked in the banking context. And the banking context in the social signal processing, we have a lot of social data. That means you may be seen many times you get a call from the call center people and ask for your credit card required, personal loan required kind of things, right? Or maybe if you are a customer of a bank and you may call the bank and ask that one, okay, what is my loan interest rate, current loan interest rate? Okay, or maybe you can somebody can ask that one, why suddenly my EMI was increased, right? Or you can say why you are giving to the 0.75% of a rate you decrease for other customers, by not why. So you may be having a very good number of questions you will ask the call center, right? So the basic idea is it possible? Is this possible to identify the dissatisfied customers? Because what will happen? All the conversations are recorded. And maybe you may be observed when you are getting some kind of a call center things, they say we are recording your call for the quality purpose, for quality check purpose, right? That means all the conversations they will store, right? They store, and periodically the manager looks at some of the randomly pick some conversations and we listen it and see whether the customer is satisfied or not satisfied, right? So for this particular banking which we worked for, this is also again a US bank. Okay, you can see there is approximately 500 calls per day for one operator. So there may be so many operators, right? For a bank. The calls could be on intraday trading, margin call, dispute, security, so many things. So about 10,000 calls from one region and more than 1 billion calls across the globe. So you can see how much data size is going away. So all these calls are being recorded and used for quality purposes, and particularly they want to identify the dissatisfied customer. So our problem statement lies with this dissatisfied customers. So the range of data you can look at it could be like a 1 petabyte to a few zettabytes per month. So that means if you're having a few lakhs of conversations, and it is very difficult even for the managers or even for the maybe few number of managers to look at the calls and identify whether anybody dissatisfied or not. So that means, is there any way to identify the calls which are actually converted into meaningful transaction with customer satisfaction, right? And the consequences if not analyzed. Suppose a particular dissatisfied customer is there, if this was not picked up by the randomly when picking, not picked by the manager, so the customer over a period of time he may move to he will close account here and move to the another bank. So competition, correct? They are heavy competition. So if you have more number of customers are leaving, then of course you have a lot of effect on the businesses. So now what are the challenges here? Can we discover the dissatisfied customers conversations, right? From the available large repository of the conversations. So that's the challenge which you are facing. So now how we can find the dissatisfied customers? Is it possible to find the emotions can be discovered from that from such kind of a conversation? So that means this emotion discovery, it can concentrate on the levels of happiness, because usually they have these emotions, right? In the literature, so you can find a lot of papers are there. They will always talk about this these things: happiness, sadness, anger, disgust, fear, surprise. Right? These 6 are there. Of course, they usually go for 7 also. But this is here we are taking the 6. Yeah? And to detect the feelings of the customers and eventually improve the user experience. Improve the user experience. So this is what we are now focusing on, this emotion discovery. So of course I have taken this picture from the internet sources. Usually, of course, this is not our work, but this is just to show that how these dialogues will happen. The kind of a facial expression, right? This is a facial, and the speech also which is there. It could be emotion or sentiment, right? Could be like a positive sentiment or negative sentiment or neutral sentiment kind of things, right? And even the emission of levels of the emotion could be like a surprise, neutral, surprise kind of things, anger. You can see it from this one, right? So yeah, this was similar thing that we try to adapt for our purpose. Our thing is, can we develop a multimodality framework? So we want to develop a multimodality framework, and where we have a both sentiment detection and as well as emotion analysis. Okay, the data set can be the text, image, audio, video, and even the facial expressions and body language. So all the things will happen, right? The gestures that are coming up, right? The kind of expression they are making, even the kind of eye gaze, right? How it is happening. So everything is making a part in analyzing it, whether the customer satisfaction levels or not. Of course, we have only taken about for the initial study, we have taken only the image. That means from video we taken the image frames. Okay, and then we have taken this audio. That means the speech. We have taken the speech data, and the speech also we converted into text. So we have taken these 3 modes for our study purpose. So that means these are the image, speech, and the text analysis for both sentiment analysis and the emotion analysis. So we have gone for the 2 levels of the synthesis, where in the first one we are trying to find the emotions from the signals. That means from the audio signals, right? We have the audio speech means audio signals we are having. So we are trying to find this one, audio, and then from the same signals we convert it into text, because of course this we use the Microsoft converter, speech to text converter, but we have done our analysis on the text also. So we got the emotion, and then we got the sentiment. We are combining how it is happening, the fusion, right? And third one is we also taking this face. So from the images we know the facial expressions, So we try to explain how the facial expressions are contributing to the emotion, and then we are adding this. So that means these three signals we are having from the one conversational signal. This is a conversational signal. So we have the text signal, audio signal, and then image signal. Okay, and we did the sentiment analysis, and we did the emotion analysis, and then the emotion. This. So see, the idea is, of course, the pictorially you can see this is like a this is a uni model. Correct? We are taking only one model and trying to doing this one. Correct? This is another model, another uni model. Here the modality is audio. Here modality is text. Here modality is image. Correct? The thing is, we need to have a combination of these things. That is where, if you want to get a good analysis. So we will develop this. Our multimodality framework is actually based on this. And this is the entire framework where we have this conversational AI techniques, the fusion of the three modes, where the speech, text, and video. Right? Usually, when you are saying any multimodality framework, the people will look at about this the three V's, like a voice, verbal, and vocal. Correct? There are three V's again we are having. So similarly here you can say we are taking this vocal, that is like a speech, verbal like a text. I forgot what is the third one. So that is video, right? So for these three, we have taken emotion detection. Taking the text part was given here, and you can see. I forgot my specs there, but you can see these are how the segments are happening. See what will happen. Each and every segment in the text will happen because this is like a conversations continuously coming, right? So the segmentation also will be a major impact on how to segment the given the text. So where you take the text, and even you can see the turn each conversation. Conversation is usually bimodal. Right? You are also talking, and then the customer care person also talking. That means it's like you need to identify this user 1 and user 2 if you look at it. So we need to separate data from user 1 and user 2. So these segments we need to identify, and then those segments are given to the our sentiment classifier, where we use a lot of LSTMs, multiple by LSTMs we used it to do this one. And of course we use finally the softmax function to the sentiment polarity, and the sentiment polarity coming to the given signal. Similarly, we also taking this speech signal, speech signals, there's audio signal, then this is the video, and then the identifying the features, and then use this CNN classifier. And these features are not these features which are doing with the CNN, right? But for the conversational purpose, we are taking those features and then giving this emotion signal. So this is a combining thing is giving this prediction to the one here. So now here for these things, we are trying to find the dependency matrix, and then fusing here and try to find the emotion. Of we use the conversion today to find the emotion detection. Okay, and this these things will be given to the for the CNN classifier for prediction, the final emotion prediction. Okay, so our things will be looks like a more on this one like a we are saying emotion embedded classifier. So our mostly our portion is that one how to fuse these things from this dependency matrix and then fusing the things. This is what our mostly work is how to embedding the aspects of it and getting it. And then there's the attention models and then representation models, because we need to represent, right? So usually if the unimodal representation is different from the multimodal representation, right? So then apply that unified model, unified representation can be given to the classifier and then predict the emotion one. And also we have a feedback loop also to get the we are still working on this feedback loop more on this one. So that's why we say that can we use the reinforcement learning here to do this one. So our idea is this the deep reinforcement learning, it may lead to the shift in the both the NLP and computer vision. So this is the kind of analysis we have done. This is like the emotion analysis of particular wave file, and then some samples data we have taken here. And our observation here is why I'm saying these are the important. Even yesterday, some kind of a tutorial was happened for in one of the conference where I was part of it. So they're saying that you can have a model. Each model you can have a different representations. Okay, and you can the representations you can use it and to do the analysis. The thing is here you can see the beautiness of in this analysis. The people when you have this emotion means this is from the speech. Okay, the sentiment is from the text data. Okay, the text was this speech is converted into text, and then we have done the same because speech and text are both are same for one particular sample. Right here, this from the speech, these things were there. These were extracted, and the sentiment, but the same signal is the same for each one. So now you can see this kind of a table when we got it. Now you just look at this kind of a data. So you can see the emotion is very happy. That means emotion is from what? From speech. That means the person is speaking very happily. That means his tone is because based on the how you do speech analysis, based on the tones and notes and everything, right? The tone is very good, but he is using very harsh words. Suppose if you go for uni model, only model of this one, and you may be land up with saying that when the people, these people are belongs to the happy, right? That means all these 14 people here belongs to say that happy. But if you closely look at this, you take the second mode also, modality also, like text, you can see out of this one, the 6 people, they are very using harsh words. That means they are in the negative sentiment they are having. You cannot treat them as a happy customers. You have to say that they are the dissatisfied customers, correct? So the similar kind of analysis maybe also happen with the other things also. That means you see one of the representation, though you are representing here these elements, you want to have some kind of a combination here. You can say joint representations. But the problem is one is going in a one direction. Some of the samples, some of the things are going other direction. And till now, there's not amount of good research that happened to how to correlate these two things and have a finally you can say maybe you can have a CNN classifier, maybe any other classifier, transformers, everything you can say. But how you can this will learn from such data, right? So that's still a good research problem to handle it. Of course, from facial recognition, of course, this is also directly we used a tool which is providing this facial recognition. So I think my time is up. I think 12:45. So I can take some questions because there are so many works we have done in our industry. This is a natural language. If you give a natural language query, how you can address this? We develop a cascaded CRF one. We have patent also on this. Okay. Then how to analysis can be done on the natural language queries, because usually we do not know the web databases, how the schema of the database, right? So then how we can retrieve the information from that one. And then some of the work we did is shopping path assister. When you go for a shopping, how we can develop a optimal routing, and then from the optimal routing, again, can you find the profitable paths, and from profitable paths, is it possible to store the pathways? Right. So this optimal routing plan, and then discovering the profitable path and clustering pathways, how we can do, because to use this self-spread optimization, right? Some of the works we have done like this, and from this Huz group, how we can do the crowd management, some kind of a time series analysis we have done at the time T1, how the density is moving from time T1 to T2. Then auto warranty claims, how the early warning tool can be developed for the warranty claims, kind of thing from the textual data. Then autonomous vehicle navigation, a lot of image analysis. So a lot of work we have done in the industry by developing these applications. Okay, maybe I will just skipping these things, and then a lot of things. Okay. So yeah. So one thing is, though we are having a very good sophisticated tools, and we can say we have a good number of knowledge, amount of knowledge we are having as a human being, but we feel that we have a good common sense as a human beings to take a decision. But you can see the common sense is also not so common, right? Is the unbox it. Okay, so today many of the models people are trying it out. Can we have a common sense reasoning? Can we develop good algebra for that? As I mentioned, like can you get an algebra of one representation, another representation to be adding it, right? So or maybe one is positive, another is negative. So how to doing it? So a lot of work is happening in this one. So this is the last session. So thanks to all of you for the patience. If you have any questions, I can take up few of the questions.
Thank you very much, sir, for your exhaustive and very important and informative session, sir.
Thank you. Thanks to all of you.
Yeah. My dear participants, please, it seems as of now we have not posted any questions in the chat. Please, you can ask directly with sir, or you can even post in the chat box also.
hope that people are exhausted for all this 1 week program, and then
Yes, sir. Yes, sir. Yes, sir.
so they can.
They almost, sir, some lectures like, somewhat in a completely in a research direction, sir.
Yeah.
People whoever are working in the direction, then only they can understand completely.
Yes.
Definitely, even all members will get the complete insight in this, sir, the depth of this. Surely participants will be motivated in this direction. Participants.
Yeah, if they don't have any questions, thanks to for all of you for your patiently hearing it.
Yes, sir.
Spending time on this one. Okay. Thank you. Thanks to all of you.
Yeah, thank you very much, sir. Just I request Madam Radhika to propose vote of thanks for this session, sir. Then after 5-10 minutes break, then I will start the valedictory session, sir.
Good afternoon, one and all. It's my privilege to propose vote of thanks for last session on 1 week ISTE-STTP on machine learning applications research challenges 2020. I would like to extend my special vote of thanks to Professor Radha Krishna sir for sharing us a valuable information on machine learning trends and its applications. And the real-time example that you have taken is social networks and streaming of data, which is a very important thing to take any decision. An important aspect from machine learning is how to stream data and what is the sequence of it, and the machine learning techniques which can be applicable for different usage. And the important note that is multimodality AI, which is a very important thing. I think every participant have gained a very good knowledge on that, which sir has explained it in very brief way. Thanks a lot for sharing us, sir. Thank you.
Yeah. Thanks to all of you.
Sir, thank you very much, sir. Sir, Gupta sir is about to join, sir, maybe in 5-10 minutes.
Okay. I will wait. Yeah, I'm here only.
Yeah. Please. Just you take 5-10 minutes break, sir.
Yeah, sure.
So that I'll give you call once again. Thank you.
I do not know how much time I will have with my power, so I will be there. I have on the UPS now, so.
Okay.
Yes,
Yes, sir. Yes.
yes.
Now, hardly once it session will start, sir. Hardly within half an hour it will.
Yeah, I will be there. In case there's any problems there, then you can.
Sure, sir. Yes, sir. Sure.
Yeah, I'm here only.
Yeah, sure, sir. Thank you. Yeah, very good afternoon to all of you, my dear participants. I'm very sorry to inform you that there is minor delay in the schedule. Now, valedictory function is again postponed 15 minutes more. 125 now, 125 plus 15 minutes, 140. Sharp will try to have 145 here because we are going to have a guest, Dr. AVSS Kumara Swami Guptha Garu. He is from JNTU Hyderabad. Sir is Telangana ISTE chapter secretary because Sir is giving a presentation in JNTH regarding NBA. So that at 1:45 sharp, we'll have the valedictory. By that time, please, you can have your lunch and be back by 1:45, my dear participants. Thank you very much. Sir, very good afternoon, sir. Gupta, sir.
Good afternoon.
Just 1 minute, sir. Radha Krishna గారిని
You take your own time. No problem. No problem.
ఎవ్రీథింగ్ ఇస్ రెడీ సార్. సార్కి మీరు వచ్చాక జస్ట్ 1 నిమిషం ముందు చెప్తాను చెప్పాను.
Right, sir. Please.
సార్ గుప్తా సార్.
Sir.
సార్ ఒకటి అంటే మీ వీడియో మీది అంటే ఫేస్ కనిపించట్లేదు సార్. ఎస్, నౌ ఇట్స్ వెరీ క్లియర్ సార్.
Okay.
స్టార్ట్ చేస్తున్నాను సార్.
చేసేయండి. కార్లో ఉన్నాను, ఒక 2 minutes లో దిగుతానులే, పర్లేదు, ఏం కాదు.
అయితే నో ప్రాబ్లం, 2 minutes తర్వాత దిగుదాం చేద్దాం సార్.
ఒక 2 minutes, అదే పర్లేదు, మీరు స్టార్ట్ చేసుకోవచ్చు. ఏమో
సార్ రిపోర్ట్ చదువుతాను సార్ ఆ టైంకి. Respected today's guests for our valedictory program, Mission Learning Applications Research Challenges, which is ISTE-STTP approved 2nd to 7 November 2020 valedictory program. Dr. AVSS Kumara Swami Guptha garu, who is Professor and Head, Mechanical Engineering Department, JNTU Hyderabad, and ISTE EC member and ISTE Secretray cum Treasurer, Telangana section. Dr. P. Radha Krishna garu, who is presently Professor and Head, Department of Computer Science and Engineering, NITWarangal, served as the resource person just before this valedictory session, today's second session. Our Director, Dr. C.V. Krishna garu, my coordinator, Dr. K. Rameshwara garu, Dean School of Pharmacy and Management Sciences, my respective heads of various departments, other invitees, and most importantly, the participants of our program. Very good afternoon to all of you. My heartfelt welcome all of you to our valedictory session of our program. The first item of our program is program report by the coordinator. I am going to give the report of our program in a very brief fashion. This is once again Dr. G. Janardhan Raju, one of the program coordinator of this program, me, Dean School of Engineering and Professor Mechanical Engineering Department of our institution. For this program, 85 participants have registered across the nation. Participants, they are from different backgrounds. Majority of the members from computer science and engineering background, and next to mechanical engineering background, civil engineering background, and even few participants are from the software industry who are working on latest technologies, DevOps, and even other machine learning area. And we have one participant who is registered from Dubai. So that we have very good mix of participants across the nation. Then as far as the resource persons are concerned, just let me give the list of resource persons who have contributed, who have extended their services to this program since day one. The program started on 2nd November 2020, that is Monday. It was started with Dr. Rajiv Srivastava, Professor and Head, Department of CSE, Indian Institute of Technology, BHU Varanasi, who was the chief guest of this program, first day inaugural session. Then guest of honor, Mr. M. Kumara Reddy, Director, Sangam and EIESB Software Solutions Private Limited. In fact, we are organizing this program in association with Sangam IT Solutions. Then the first day, second session was by Dr. I. Jena Jacob Madam, who is Associate Professor, Department of Computer Science and Engineering, Geetham University. Madam's lecture on Foundation of Machine Learning for Data Science. In second day, it was started by Mr. M. Kumara Reddy, Director, on digital transformation, revolutionize customer experiences. Then second session, great personality once again, Dr. Atul Negi, Professor, School of Computer and Information Science, University of Hyderabad. Sir's talk was on artificial intelligence for social good. The day third session was by Mr. ML Venkat, Director, Native Tech Hub Software Solutions, which was on hands-on Python, covered NumPy and Pandas packages. Then next day, third, which is on fourth, Machine Learning Supervised Learning Algorithms by Dr. Aruna Malapati, Professor, Department of Computer Science and Engineering, BITS Pilani, Hyderabad campus. Then second session was by Dr. S. Vishwanatha Raju, Professor of CSE, JNTU, Vice Principal, JNTU College of Engineering, Jayapriya, which was on Artificial Neural Networks with Real-Time Examples, Part 1. Then third day, afternoon session again, Machine Learning Hands-on and Supervised Linear Regression Algorithm and Unsupervised Algorithm. Then fourth day, again, by Dr. S. Vishwanath Raju, Professor of CSE, again Part 2 of ANN. Then fifth day, on 5th November 2020, second session was by Dr. Ramakrishnan AG, who is Professor, Indian Institute of Science, Bangalore. Again, Dr. P. Krishna Reddy Garu, who is a renowned professor in Data Science and Analytics Center, IIIT Hyderabad. Sir was taken the session on experiences of building IT-based systems to deliver actionable agricultural information to Indian farmers. First session was by Mr. M. Venkat, hands-on experience again. Then second session was by Dr. Salman Abdul Moiz, which was on data visualization, Professor, Department of Computer Science and Information Science, University of Hyderabad. Then yesterday afternoon session was by Dr. Vadlamani Ravi Garu, who is Professor, Institute for Development and Research in Banking Technology, which is popularly known as IDRBT, which was on research challenges and applications of machine learning. Then today, morning session, which was session was by Dr. Jayapriya, Kalyanakumar, who is the Director, Research Associate, Win Solutions, Tamil Nadu. The topic was Deep Learning in Computer Vision. Then just before this valedictory session, session was by Dr. P. Radha Krishna Garu, who is Professor and Head, Department of Computer Science and Engineering, NITWarangal, session was machine learning trends and applications. With the great support of all the resource persons, with their in-time support and coordination, we could able to have all the sessions. It seems there was no deviation at all as per the schedule. I really thanks from my heart to all the resource persons for extending their coordination and complete cooperation, complete support. Then we could able to organize this program in a very right time without any deviation. But when we look at the topics which we have covered, are even by our renowned personalities, data science, or even artificial neural networks, Python, or even hands-on experience, artificial intelligence, like even trends and applications, deep learning, computer vision, computer visualization, natural language processing. The participants, whoever are having reasonable knowledge on this topic, no doubt that they might have got some sort of direction in their research. At the same time, the participants, whoever are not having some sort of knowledge in this direction, they might have got motivation by this time. Hope the objective with which we have initiated this program as a coordinator, I feel hope to definitely it will be taken into consideration, and this has been reached to all the participants. Now, as two guests we are here. In fact, Gupta sir, just before 5-10 minutes, sir was very busy in delivering his NBA presentation because of his busy schedule. Still, sir is with us. I am really thankful, sir, from my side, on behalf, my personal behalf, and on behalf of our institution, for your commitment and immediate consent to be as a guest and again with us. Again, sir, thank you, sir. Again, Radha Krishna, sir. In fact, session was last day. Sir has given complete briefing on machine learning trends and applications in a very, complete insight sir has given. One session, sir has covered all the concepts. No doubt that the last session will definitely has already motivated, and participants will carry the same even for future, sir. Thank you very much from my heart, sir. I'm telling you, for a really session was very nice, sir. It's a really very good motivation to all the participants.
Thanks.
And even I request you to be again guest again after half an hour time. Once again, thank you very much for your gracious presence with this.
Thank
now, you. Yes, sir. And especially very importantly, participants, because of participants' valuable presence, we are here and to organize this program. Any program will, in fact, will become success when we have the reasonable number, good number of participants with good, involvement of participants in the program. Every one of you are really supported well in organizing this program without any sort of disturbance. Now, we require very valuable feedback, means, in fact, to improve our system for all future programs. Now, I request all the participants to give your feedback very openly, whether it is good things or even things to be improved. So that surely we will take your all sessions will be into consideration. We'll try to we'll improve our all improve the quality in future. Thank you very much. Now I request our all participants to give your valuable feedback, please. You can unmute yourself and you can give your valuable feedback, my dear participants. Thank you. My dear participants, hello participants.
Good afternoon to all honored guests and organizers. I, as a participant, my name is Bhavana, and I have listened all the 1 week online STTP on machine learning applications research challenges. It was a wonderful session, and I have gathered a lot of knowledge regarding what is machine learning, what are the applications of it, and what is NumPy, what is Pandas. I have got clear explanation by the resource persons and the eminent speakers who have spoken very well in the different technologies as we are coming forth for doing our research and all. So I am very happy and glad that we are looking more forward for these sessions to be conducted. Thank you very much.
Thank you, Madam Bhavana, Madam, for your valuable feedback. My dear participants, please, other members.
Good afternoon, one and all. This is Srinivasan Reddy from Srinidhi Institute of Science and Technology. I have attended almost all the sessions conducted on this particular machine learning, its applications and research challenges. I know the pains that I have taken by Dr. Janardhan Razu, who is closely associated with me, close friend of me. He invited industry people and academicians from JNTU and NIT, Central University, and all reputed universities. He invited the speakers, and all the lectures, invited talks are really very good, very useful. We have known about what is machine learning, what is feed forward, feed backward, supervised learning, unsupervised learning. What are the research areas that can be where we can focus on these things. But as we are from mechanical engineering background, we need to focus and we need to analyze where this machine learning can be used in mechanical related applications. Most of the speakers talked about the applications of machine learning related to computer vision, image processing, which are related more of electronics as well as computer science background. But we need to search for the applications of machine learning, especially to mechanical related area also. Then definitely this machine learning will also be used in interdisciplinary branches like mechanical also, so that there will be a bright future for mechanical engineers as well if we can able to apply the concepts of machine learning in mechanical engineering. Uh, I really thank all the speakers and organizers to give enlighten us on the latest topics like machine learning to all the participants. I wish all the best. We are we are expecting such more programs from the organizers so that we can learn more from the speakers. Thank you very much, Janardhan Razu and his team. Thank you. Thank you.
So thank you very much, sir, for your valuable feedback.
Thank you, sir.
Yeah, thank you, sir. My dear participants, please. Participants, you can give your feedback. Other participants can come forward to give your valuable feedback. Feedback is very, very important for all future programs. See, almost after 1 week, your feedback will motivate us in which direction we have to take up our put up our efforts to satisfy participants completely.
Good afternoon, sir.
Yeah, good afternoon, sir.
Myself, Sai Venkata Krishna, sir, from Mega Institute of Engineering and Technology for Women. It's my pleasure to give the feedback on this 1 week short-term course. At the outset, I would like to congratulate Dr. G. Janardhan Raju sir for organizing this workshop along with other coordinator of CSE department. And this particular course has given enough knowledge on machine learning and its applications, where it started with very appropriate at the ground level, where we had the foundations of machine learning by Gina Garu, and then a few interactive sessions of artificial intelligence and digital transformations by Atul Negi sir and Vijay Kumar sir, and a few interesting supervised learnings and in a practical manner, which was explained by Aruna Garu, and a few interesting things on Python, which was dealt by Venkat sir, and his interactive sessions was extraordinary. And we had some research challenges of machine learning, which was dealt by Ravi Garu and so on. That this particular workshop has been framed in such a manner that even from the basics to the end, it covered all the things of machine learning and its challenges, which gave some interest for the people who are not apart from the CSE department. I belong to mechanical engineering department, and it gave me enough knowledge that yes, this particular machine learning can be done by any other departmental candidate. So thank you, sir. Thank you for giving me this opportunity to attend this course and learn the latest concepts of the machine learning and its applications. Thank you so much, sir. And I wish NNRG team and its group for organizing this wonderful STTP. Thank you. Thank you so much.
Thank you very much, sir, for your valuable feedback. Thank you very much. I'd be really very happy at least more 2 participants will take an initiation to express your valuable feedback. My dear participants, please come forward to express your valuable feedback, which is very, very important, and it will give motivation to our entire team for future.
Good afternoon, sir. I'm Sahiti. I'm pretty much thankful for you for this 1-week program. I have learned many things, and as a research scholar, I have got to know the differences between the each and every technology. And I even got an idea that where should I implement few algorithms, and it was very useful session. I'm pretty much thankful for you, and I'm expecting more and more again. And I'm congratulating each and everyone who participated in this. Thank you, sir.
Yeah, thank you, madam. Thank you very much for your valuable feedback. Last one participants, please. Anybody can take an initiation to come forward and express your valuable feedback. One participant last. Yeah, thank you very much, my dear participants, for your valuable feedback. Whoever have come forward by sparing your valuable time. Now, next item of our agenda of our valedictory schedule is introduction of the distinguished guest, Professor P. Radha Krishna Garu, who is the Professor and Head CS Department NITWarangal. In fact, for a valedictory function, there are even other few new members are added, so that it's my responsibility to give a brief introduction of sir, even though sir was the resource person for the just in the previous session. Maybe I'll take less than a minute to give highlights of sir. Professor P. Radhakrishna, presently working as the Professor and Head Department of Computer Science and Engineering. Sir's areas of interest are data mining, big data, machine learning, databases, and workflow systems. Radhakrishna has been in this profession of research, development, and technology adoption for about 28 years. He is currently, prior to joining NIT, Dr. Krishna served as principal research scientist at Infosys Labs, Infosys Limited, Hyderabad, where he was associated with research projects leading to futuristic intelligence systems and analytical solutions. He conceptualized numerous research projects in the areas of CRM, social network mining, web sequence, text and image mining, e-check cleaning and settlement, and financial inclusion, and associated in building innovation labs for leading industries. Dr. Krishna also served as a faculty at the Institute for Development and Research in Banking Technology, IDRBT, which is arm of the Reserve Bank of India. Sir was advisor to many public and private sector banks in India for implementation of end-to-end enterprise-wide data warehouse and business intelligence solutions. Dr. Krishna was also a member of IT Advisory Committee, Insurance Regulatory and Development Authority, which is popularly known as IRDA, India. Sir has been a member of research advisory committees of several academic institutions. Also has been a member of the editorial review board of international journals and reviewer of several international journals, including IEEE transactions and knowledge and data engineering, IEEE transactions and services computing, information sciences, data and knowledge engineering, information system frontiers, and soft computing. Dr. Professor Radha Krishna has double PhDs, first one from Osmania University and second one from IIT Hyderabad, and 15 patents are granted. And in fact, these are there in his source credit. Authored or co-authored 6 books and have over 100 publications. With this little bit introduction, now I request our guest Professor Professor Radha Krishna Garu to address the gathering. Thank you, sir. Over to you, sir. Radha Krishna, sir.
Yeah, good afternoon to all of you and respected dignitaries on the chairs and then the participants. It's a very nice experience interacting with all of you on this occasional valedictory function. As you can see, this machine learning actually having a change in the paradigm shift of where the people used to think about in a normal way of thinking process. And now they are completely transformed into like a new age kind of a systems. And this is one of the great opportunity to interact with people and also share knowledge among ourselves as a faculty members, as a part of the researchers in this field. We have to think about how to come out with the new algorithms and new things. And one of the aspect is, though many people will think about these patterns, the kind of a significant ideas coming from the systems, one can easily think about this. Learning today is very easy. And you may be seen there are a lot of big vendors like Microsoft, Amazon, Google. All these people are developing, they are investing a good amount of money on these developing solutions. And even they are improving the technology also. At the same time, they are also giving us a lot of tools to adapt it. And if you go to Google, there's a Google Cloud Vision API. Similarly, if you go to Microsoft having a cognitive technologies where you can able to just plug in your texts there and you can get the sentiments. So like that, the wonderful tools are available today, mostly available freely and ready to use for us. And it is only up to us how best that we can utilize the tools. And even the learning paradigms also not very difficult in this machine learning task, which we are there 3 to 4 decades back. It is very hard. Even learning is one aspect and understanding the algorithms is different. And then deploying that one is more difficult. But today we have plenty of systems are in place. We have a cloud infrastructure, so whatever the kind of a complex algorithms you want to run, they are available. And even the knowledge is also can be gained more easily. And you can see the evolution of how it is happening. Even you can look at the kind of a learning from the lot of things can be learned from the nature also. It's not only from textbooks. We can also see how the learning can happen from the nature. Suppose you can see how the birds will fly. So they will go in a different kind of a patterns, which we never envisaged because they didn't train for anything. But they can form a good shapes and everything. Even the same behavior you can find out most of the natural insects, animals, right? So the same thing that we can also adapt and then go ahead and then doing the things and implement it. One of the best thing is in machine learning industry is you have to practice it. If you not practice it, then whatever you learned will not be at all much useful. So today tools are available. Data is also available. Interestingly, data is also available. So it is up to us how much will benefit from us. And it is good also to have this kind of a workshops to share knowledge and also to learn from each one of the participants also. So how the kind of the different questions that they are having, or maybe they are having some kind of different problem statements. Maybe if you can work it out your own problems, and maybe that is a good idea to share and start working in this area. And with these few words, I wish all of you have a great success, and I think that you are having a great experience in understanding it. And also you will share again to the other members, other educators who are interested in this machine learning area. And I wish all the best, and I also congratulate the organizers for giving me opportunity to be participate in this valedictory section. Thanks to all of you.
Thank you, sir. Thank you very much once again for your valuable presence. in our valedictory session, sir. Thank you very much for your motivational words. Now, it's my once again pleasure to introduce about our distinguished guest for our valedictory session, Dr. AVSS Kumara Swami Gupta Garu. Presently, sir is Professor and Head, Department of Mechanical Engineering in JNTU College of Engineering, Hyderabad. Sir's areas of interest are thermodynamic analysis of advanced power cycles, combined cycles, clean coal technologies, coal classification, biomass energy, circulating fluidized beds, and finite element analysis. Dr. Gupta has completed his bachelor degree in mechanical engineering from JNTU College of Engineering, Anantapur in 1993. Master's degree in mechanical engineering from Regional College of Engineering, Warangal, and doctoral degree from the Indian Institute of Technology, Kharagpur in the year 1999. After obtaining the doctorate degree, he joined as Assistant Professor R&D Division, Tata Steel, Jamshedpur from 1999 to 2001 and came for teaching in 2001. He joined as Assistant Professor in JNTU College of Engineering in 2001, promoted as Associate Professor in 2003 and as Professor in 2011. He did his post-PhD research work at University of New Brunswick, Fredericton, Canada in the year 2004. Sir has done several administrative responsibilities at JNTU as Head of the Department, Controller of Examinations, TECUP3, ATU Coordinator, Special Officer, Nodal Center in charge, Officer in charge of Examinations, Hostel Manager for both boys and girls hostels, Deputy Warden for both boys and girls hostels. Sir has visited different countries to present papers and post research work, namely USA, Canada, Singapore, Malaysia, Hong Kong, Thailand, Indonesia, etc. Sir is a National Executive Council member for ISTE for 2020-24 and Secretary cum Treasurer of ISTE Telangana State Section. Sir is a life member of ISTE and ISHMT. To his credit, Sir has published more than 175 papers in international and national journals and conferences and already guided 23 doctoral students. 8 more students are pursuing their doctoral work under his able supervision. In addition, Sir has guided 75 post-graduation projects and 65 undergraduation projects. Sir is a member for NAC and AICTE peer review committee member. He received second best paper award from Tata Search Journal in 2001 and certificate of merit for the paper published in the Institute of Engineers Journal in 2000. Professional experience as usual, in both Sir is having both industry and teaching. As far as the projects are concerned, research projects and experimental investigations and augmentation of heat transfer in a shell and heat exchanger funded by TECUP3. In 2009, again, one more project, which is on experimental investigation of the spray characteristics of nanoparticles blended water diesel emulsion fuels funded by TECUP3, which was sanctioned for 3 years in 2009. With this little introduction, I welcome you, sir, for our program. Thank you, sir. Thank you very much. Thank you, sir.
Thank you, Professor Janardhan Raj Garu.
Thank you, sir.
Respected dignitaries on the chair today, Dr. Radha Krishna Garu, Professor and Head from NITWarangal, the Dean Janardhan Raj Garu, and the Coordinator and Computer Science Head, Professor Krishna Reddy Garu, and other heads of the departments, participants. Thank you very much for inviting as a guest today for this ISTE program being organized by Nalla Narasimha Reddy Group of Institutions. At the outset, I would like to congratulate the team members who are able to successfully conduct the 5-day workshop under the umbrella of ISTE, which is an interesting and important topic, machine learning. Right? As you are aware, if you see the undergraduate programs which are being added recently in the curriculum of JNTU, almost like 18,000 seats have been included in Telangana state in the area of computer science specialized undergraduate programs. First time we may find such type of courses. In that, one of the courses is artificial intelligence and machine learning. The lot of seats are being incorporated, and it is high time to give training to the faculty members of the computer science to understand, to do research, to take the challenges in the area of artificial intelligence and machine learning. And I appreciate the Nalla Narasimha Reddy group of institutions has taken the initiation to give the training program on machine learning, which is vital and important for the latest technologies. And after seeing this background and report of this particular workshop, I'm able to notice that almost like more than 80 participants have learned this advanced topic. It is almost like a new topic, and it is very much useful to the participants so that in turn they can disseminate this particular knowledge to their students in the during the academics. As a secretary and treasurer of Telangana State and Executive Council of ISTE, I must thank the Nalla Narasimha Reddy group organizing many such events under the umbrella of ISTE. I am very much thankful to them, and I appreciate the efforts made by them. When you come to the technological developments in computer science, even when we were the students at IIT Kharagpur, when we were doing the research work, we were having the friends of in computer science. What they do, they try to update their knowledge, and the technological developments are happening in the computer science in day to day. We used to comment them. So if the new technology come, that research scholar goes to the library and they try to learn something from that technology. And by the time he returns and implements, the new technology might have been come, and again he is going to the library. That is the way the technological upgradations are happening in the computer science, because of which everything is in our hand now. Even all mails, applications, processes, procurement, everything can be done by the single mobile. Such a technological developments are happening, and the lifestyle has become so simple for all the members and the public because of these applications, right? These technological developments are to be implemented into the curriculum, and at the same time, the teachers are to be trained effectively so that they can impart knowledge to the students in that particular area. I may not be much expert in the area of machine learning. However, I know the importance of this machine learning and how it is very much useful in mechanical engineering. The technological development, the missions nowadays are being operated automatically because of this machine learning and artificial intelligence. And the trends, futuristic trends and everything can be known from the artificial neural networks and so on. So this particular technology is very much useful. I hope you might have learned by the different experts, and you must have acquired good knowledge with this FDP. I hope this FDP might have been very much useful to you for doing your research as well as for teaching. I take this opportunity to thank the organizers for conducting this event and given me the opportunity. I congratulate them for successfully conducting such a wonderful event. Thank you very much, and I wish you all the best. Thank you, sir. Thank you.
Thank you, sir. Thank you very much for your gracious presence and your motivational words. Always you are a well-wisher, because we were really very happy that your gracious presence was there even our last program.
Thank you.
Thank you, sir. Thank you very much, sir. Now I request our coordinator, one of our this program coordinator, Dr. K. Rameshwaraya, Professor and Head, CSE Department, to propose vote of thanks for our program.
Thank you, sir. I'm privileged to propose vote of thanks for the last day of national level 1 week IST STTP, ISTE-STTP on Machine Learning Applications Research Challenges, MLARC2020. I thank all the resource persons who have supported from the day one onwards. Firstly, Dr. Raju Srivastava, Professor and Head of the Department of CSE, IIT Varanasi, and Mr. M. Vijay Kumar Reddy, Director, Sangam and EIESB Software Solutions Private Limited, who is also supported industrial support given for our program. And Dr. I. Gina Jacob, Associate Professor, Department of Computer Science and Engineering, Geetham University, Bangalore. Dr. Atul Negi, Professor, HCU, Mr. Venkat, Director, Native Tech Hub IT Solutions, Dr. Arna Malpadi, Professor, Department of Computer Science and Engineering, BITS Pilani, Hyderabad campus, and Dr. S. Vishwanath Raju, Professor of CSC, Vice Principal, JNTU College of Engineering, Jagityal, Dr. A.G. Ramakrishnan, Professor, IISc Bangalore, Dr. P. Krishna Reddy, Professor, IIIT Hyderabad, Dr. Salman Abdul Mois, Professor, Hyderabad Central University, Dr. Vadlaman Ravi, Professor, Institute for Development and Research in Banking Technology, Hyderabad, Dr. Jayapriya Kalyanakumar, Director, Research Associate, Wind Solutions, and today's guest for our valedictory function, and also resource person, Professor P. Radha Krishna Garu, Professor and Head of the Department, Computer Science and Engineering, NITWarangal, and today's distinguished guest, Professor AVSS Kumar Gupta Garu, HOD Mechanical, National Executive Council member for ISTE, Secretary cum Treasurer of ISTE Telangana State Section. Thank you very much, sir, for all your support. And our director, Dr. C.V. Krishna Reddy Garu, for continuous support and guidance, guiding us for conducting this event. And our Honorable Chairman, Nalla Narasimha Reddy Garu, providing state art of infrastructure for conducting this event. And I thank all the participants who have showed confidence on us. And lastly, all my faculty members who have supported to conduct this event in a grand manner. And I conclude my talk by saying a great quote by Mahatma Gandhi, our father of nation. Live as if you were to die tomorrow. Learn as if you were to live forever. Thank you. Thank you very much.
Thank you, sir. Thank you very much for proposing a vote of thanks. And we have recalled all the complete resource persons who have extended their cooperation and support. In fact, Dr. C.V. Krishna Garu, who is our director, because of his busy schedule, is out of our institution, so that sir could not able to join. Once again, thanks to the guest, Gupta sir and Radha Krishna sir, for your valuable presence today. Definitely, both of you made our program so valuable after completing all these sessions in the program. And once again, I thank all the participants for your active role in the session. You really gave us very good motivation in our program. No doubt that with this motivation, very shortly, probably this month, maybe 23rd November only, we are coming up one more program. Hope definitely the same sort of support and a coordination will extend in the future also. Thank you, sir. Thank you very much once again, Radha Krishna sir and Gupta sir, for your valuable presence, sir. Thank you, sir.
Thank you. Thank you. Thank you for inviting us.
Thank you, sir. Thank you. Thank you, sir. Thank you, sir. Bye.
Sir, nice to meet you, Radha Krishna Garu. Thank you, sir.
Sir, it's nice,
sir.
Nice meeting you, sir.
I am alumni of NITWarangal, sir.
Yeah. I just noticed that one also while introducing. So it's nice of you, sir.
Right.
Okay,
sir. Thank you.
Thank
Bye.
you, sir. Thank you, sir.